Hello everyone and welcome to this Blueprints Masterclass. So in this huge course, I'm going to be focusing to teach you guys everything about the blueprints. We're going to cover almost everything about it. And if you're an artist like me and not a programmer, blueprints is the way to go for creating indie projects or prototypes for your games. So the aim of this course is to teach you as much as I can in the shortest period of time. I'm not gonna talk nonsense. I'm just gonna teach you straight to the point blueprints and try to compress all the knowledge in very short lessons because my idea is to give you the full knowledge in the most short period of time because time right now is the most important thing in life. So let's start. What is the difference between C++ and blueprints? So for example, if you are not a programmer like me, C++ is the way that programmers will be using Unreal Engine most of the time. It is a language, programming language that you can use in order to create your game in Unreal Engine. However, Unreal is very popular because of the blueprint system, and that is what we are going to use. So the first, I'm going to select the Games tab. This is the Unreal Engine 5. I'm going to click on the blank, click the blueprints, and I've set up my project location. I've put a project name, maybe blueprint master class, and I'm gonna hit create. Now this is how a blank project looks like, and right now we are working with blueprints and not C++. Don't get me wrong guys, if you select blueprints and for example if you're an artist like me and you start working with blueprints, you can always have another person which is a programmer programming in C++. So the blueprints are just a visual representation that you can use to achieve your results. So they can both work in hybrid mode. So you can write in C++ and the artist can use the blueprints and you can combine them to work together. So the first thing that I want to show you is how to create a blueprint. So here in the content, you see that we don't have anything in this project. So you're gonna right click here and you have in the create basic assets blueprint class. So I'm just gonna click on it and you have different classes here. I'm gonna explain them later on in the course. So now we're gonna click on the actor and we're gonna call it BP underscore first blueprint. So BP stands for blueprint. For example, if our project is very big, I'm gonna go here in the search content and I'm gonna click BP and I'm gonna find all the blueprints that I've created in my project. So this is a fast way to find your blueprints in the project, and also the naming convention is telling the other guys that are working on this project that this is a blueprint. So now I'm gonna just double click on it. And this is my interface for my blueprint. If you are using C++, you're gonna code in Visual Studio. You're gonna see all these letters, functions, etc. But for artists like us or like you guys, we use this blueprint system. And I'm just gonna quickly cover what all the menus here are, just so that you get familiar with them. So starting from here from the left, we have the components. Those are the components that the blueprint class is holding. For example, you can have camera here, character, sword, etc. Here you have the graphs. Right now we have only an event graph, but you can add different graphs over here. Next is the functions. We have variables, we have macros, and event dispatchers. I'll be covering everything from here in the following lessons, and keep in mind that this menu is showing what our blueprint has. Moving further is the details panel, which is showing a lot of functions for our component. If I select here the default scene root, you can see that it changes to different details. Or if I click here on the event graph, we have new details loading up. So here will be the details of the objects of the components that we've selected, or the graphs, functions, variables, etc. So this is the basic, and here is a viewport that you can, rotate, scale, and move. And the next two important things is this is our viewport. We have a construction script. Here we're gonna construct scripts, and we have our event graph here. So we're gonna be working with those three over here. And when you create some blueprints, create some code, you go here and click compile, or the shortcut is Control Alt. And when you have this green tick, it says, all right, everything is okay, the blueprint is fine. But if you have different than a green check, it has some errors or warnings. And this is pretty important to check. Another thing is you have save, you have browse, you have diff, which is server control. You have find, you have hide unrelated, and a lot of other stuff. You can also simulate your components. If I click here, it's going to simulate all the components. So all the blueprints logic that we've done, we can simulate here in the viewport. And from here, you can play the level, which this play button is like this one. So this is pretty much the basics of the blueprints. The things that you need to know is the difference between blueprints and C++. C++ is coding, blueprints is visual representation of C++. But there is a downside of the blueprints. They are slower compared to the C++. So performance-wise, it is better to write pure code than using the blueprints. But for small projects and indie dev projects, blueprints is the way to go. If you face any performance issues, you can switch to C++ and make a hybrid mode to boost your performance. The next important thing is how to create the blueprint. And finally, all the layout here in the blueprints. So this is about our first lesson. We're going to continue in the next video with the fundamentals of our blueprints in Unreal Engine 5. All right, welcome back. So in this second lecture, we're going to be covering the event graph, just the basics of the event graph. So right now I'm in our previous created blueprint. Here you can see the event graph. So if I click here in the event graph, we're going to be working here a lot. Most of the time that we're going to spend in this course will be here in the event graph, because we're going to create our game logic here. So few things that I want to show you in mind. With the right click of my mouse, and I'm just dragging it, I'm just panning across this grid, holding these three event actions. So I'm just moving. If I use my scroll wheel, I'm just zooming in and zooming out. You can see that this grid is infinite, and we can create as much logic as we want. And those are the two buttons that you can manipulate the camera here and the event graph. The next thing is that you can select event and just move it with the left mouse button. And as you can see, it is snapping on the grid, which is pretty good because we can align them at the same line. So those are events that are created by default. So the first one is event begin play, which says when the game plays, those events will start that are connected to this event. And I'm gonna show you a simple hello world example. And the second is event actor begin overlap, and we have event tick. We're gonna be covering everything here in our next lessons. But first, let me show you how you can add a different event here. You can right click in the grid, just single right click. Here, right click to create a node. You have a little message. And here we have all the actions for the blueprints. There are a lot. We have a lot of actions. You don't need to learn everything at once, guys. You can use the documentation for it. But here they have different category. For example, if I want to access my collisions, here you have a lot of actions for collisions. You have a lot of actions for cinematics, and so on. Here everything is organized very well. If you want to execute some logic for your level to go from one level to another level, you can use this. The next thing is the search. This is very important because if you want a specific node to get, you just type, right now I'm gonna use the print node. So here with the print string, I'm gonna just print a hello world text. So I'm just gonna click on this print string. So now when I have my print string here in our event graph, I can move it as you can see. And here I have a connection. And now I'm gonna connect. I'm just clicking here at this arrow. I'm just dragging and releasing over here. And right now what I've done is when my game starts to play, it will execute the print string block. And here in the string, I'm gonna say hello, dear fellas, and I'm gonna hit compile. But look very carefully. We have a yellow circle with a question mark, which means our blueprint is not compiled and we don't know if it's working or not. I'm gonna hit compile. Unreal is checking if everything is okay. I'm gonna click save. And the next step is, let's minimize this. In order this to work, you need your blueprint to be in the scene, because we are creating an actor which needs to be in the scene in order to start executing this blueprint. So I'm just gonna drag and drop our blueprint here, and I'm gonna hit play. And here you can see we had a text saying hello fellas, but it disappeared pretty quickly. So I'm gonna show you why. I'm just gonna go back to my blueprint, and here from this arrow I can expand and I can access more options of this print string function. So here you can print to the screen. If I click this, turn it off, it's not going to print in my game. Here is printing to my logs, which is our console. Here is a text color. If I click here, I can change the color, let's say to green. I click OK. Here is the duration, and I'm gonna tweak it to 10. And right now our print string needs again a compilation. I just click compile, I click save, minimize, and right now we're gonna see a change in the color and change in the duration of our printing text. We have hello dear fellas, and we have green text, which is working pretty nice. And after 10 seconds, it will disappear. So this is your first blueprint connection. Thank you guys for tuning in the second lecture. I'm gonna continue showing the fundamentals of the blueprints in the next lecture. Hello and welcome to this next lecture. And I'm gonna speak about execution of the blueprints. So when you start a game here in this blueprint, the first thing that will be executed will be our construction scripts. So here everything that you have connected to our construction script will be first executed, and after that Unreal Engine will continue to the event graph. So the first executable will be our construction script, and then we're gonna move to the event graph. This is the order that Unreal Engine is executing our blueprint. And here event begin play, you can have only one event begin play, one event tick, and one event actor begin overlap. You can have only one of those three in the blueprint class. So event begin play says when the game starts, play the print string, and that's it. And when the chain of connections reaches to the end point, so right now is our print string, everything stops and everything is executed. So this is the first logic. How you can disconnect things is by holding Alt on your keyboard and clicking on this arrow on this connection, and we just simply disconnect event begin play from our print string. Let me show you the order of execution. For example, if we add another print string, or maybe let's try print text, just like that. And right now, if I connect my event begin play to my print string and my print string to my print text, what is going to happen, guys? It is going to execute first the print string, and when you have hello dear fellas on your screen, it will continue to the print text, which is what's up, and event begin play will end. So this is the order of executing your blueprints. from left to right. Everything from the left will start before everything on the right. So this is the chain of movement of execution of the blueprints. But if you do this, I'm holding Alt to disconnect. And if I connect here and connect it like that, see the flow? It will execute first the print text, then go back and execute the print string. So you can rearrange them. It is pretty important to have all these connections very clean to your eye, because when you have a complex blueprint with a complex event graph, you can get lost. The next thing is the event tick. This is very important block. What event tick does is it executes every time when a frame renders. So most of the games are rendering 60 frames per second. So event tick will execute 60 times per second. So if I put print string over here and says oops and connect this oops will execute 60 times per 1 second if my game is running on 60 frames. So this is something that you need to use with cautions, because if you make very heavy logic over here, let's say a lot of blocks, a lot of mathematics, a lot of functions, and you execute this on each frame of your game can get pretty performance heavy, and you can have pretty bad performance or FPS to your game. So to summarize the flow of the blueprints, how they execute. First is our construction scripts and everything here that we put like a logic. Then in our event graph, we have event begin play, which will play on game start, and our connections are flowing from left to right and following the execution order of our arrows. And the next thing is the event tick, which is executing a tick on each frame the game renders. Now with the new connections, so hit compile, hit save, let's minimize, and let's start the game. Hello dear fellas, what's up? And everything is executing in order. If we change their places, they're gonna switch which is one of the top and on the bottom. Let's just quickly do that. Let's disconnect. Let's move them like right here. Let's connect this one. Let's connect this one. Compile, save. And now the places of what's up and hello fellas are going to be switched. Hello dear fellas, what's up? So this is pretty much the base logic of how the blueprints are executed. Thank you guys for watching, and I'm waiting you in the next lecture. Hello again, and this is very important lecture. I'm going to show you how to comment your blueprints logic, and this is very important because of three main reasons. The first reason is it will be very organized when you have a big logic over here and just to comment different segments of your logic. The second thing is if you did not open your project for a while, you're gonna forget everything that you put in your project or some of the things. And if you leave everything like that, like those two blocks, you're not going to know what this logic does. And you're gonna zoom in and start thinking, oh, what this does. Next, let's see the connection, let's see the next connection, etc. Commenting your blocks and your logic by block is very important for you personally to organize everything and your logic very good. And later on, when you have your game created and your game becoming more complex, you can easily get in your blueprint and fix some of the things if you know where this thing is. And the third reason is because if you are not working alone and if you're working with other people and they need to modify your blueprint class, if you did not comment anything, it will be pure nightmare for them to fix your things and just to find this variable or this logic where it is. I'm going to show you right now how to do this. So I have those two print string and print text. I'm going to select them, right click, create comment for this section. And I'm going to name it print text in my game. So this is the block that is printing text in my game. And if I zoom out, let me just move the whole block over here. If I zoom out, I see that there is some logic over here. And if I zoom in, print text in my game, all right, this block is doing this. From here, you have different options from the details panel, as I've told you in our first lecture. If I click show bubble when zoomed, if I go pretty far, I have print text in my game with a pop-up bubble. So if I have pretty complex here events, I can see all the events when I zoom out. If I zoom in, this pop-out disappears. So you need to turn this on. Also, you can select a color for the bubble or a color for the comment. So let's make this green. And the color bubble will also take this green. You can set up the font size, let's say 25 for my print text, or let's say 18. And you see that the font size is changing. Now, the move mode, group movement or the comment. So if I select the comment and start moving the comment, it's gonna move without the game logic inside. I'm gonna Control Z. If I select the group movement, if I want this whole block with logic to move, I'm just gonna move it like that. So I use the group movement, I use the color bubble, show bubble, and the comment color for different sections to color code them. So for example, if this is adding health to my player, I'm gonna create it green. If this is decreasing the health of my player, I'm just gonna make it red, so it says that this is doing something bad in my game, decreasing player, making damage, etc. The next thing is that you can expand your comment tab from here, from the bottom right. You can drag like that, and you can add more blocks over here. But also you can comment inside your comment. So for example, if this is creating some big logic, I can select this, the print text, and I can hit C on my keyboard to add a comment. I hit C, and let's say this add health, and let's rename this to, double click here, make damage. So here, add health, make it green, use show bubble, but be careful because comment in a comment, if I do this, it's not gonna look pretty bad, but they're gonna overlap. So right now I have my make damage, and in this make damage I have add health. And if I start moving this block, it's gonna move the other comment too. And if I select this one, I can move this one. So this is pretty important to organize all your event graphs over here with comments for your ease. And if you're working with colleagues, so they can know your logic and which block is doing damage and which block is adding health, or etc. So this is pretty much about how to comment your blueprints. And once you're done, click compile, click save, and everything is ready to roll. Thank you guys for watching this short one. I see you in the next one. Hello and welcome to this lecture. In this lecture, I'm going to show you next step on how to organize your blocks. So let me just delete those comments. And let's create a lot more of these. And let's create a gate. Let's create a multi-gate. I'm just creating this thing in order to mess up all my connections. Just follow me along on this one. Let's connect this. Let's connect this. Let's connect this. Let's create one more. Let's connect this. And once I've did that, you see that everything is messed up and I don't know which thing is connected to the other thing. And this is simply because my lines are going behind and it's pretty hard to track them. And let's say you want to organize this, and I'm going to show you how. First, I'm going to move this a little bit like that, and I'm going to start arranging my blocks like that. Let's arrange this like that. And now this block is okay, but this line is still not great, and this one is not great too. What you can do is I can double click on the line, and it creates a node, and I can select this node and just drag it like that, and now my connection is more clear. Let's create a node for the second one. Double click here. Let's create it like that. Let's select this one and move it a little bit down. Like, I'm gonna zoom in, move it like that, and now my thing is arranged pretty good, and I can see which connection go to my blocks. The other thing that you can do is you can comment on those knots. If I click here and there are 3 dots, I click on the 3 dots and I can say this knot is executing text WhatsApp. And now I know when this connection go over here, it is executing WhatsApp. If my project is pretty heavy, I can track those knots over here, and I know what this knot is doing. And when I zoom out, I cannot see the comment. And if you want to see the comment, you need to click here this pin. And if I zoom out, I can see the comment on this connection. So this is a way how to create those connections. And if you want to delete it, just select it, click delete, and you need to connect it again. So this is about the knots and how you can organize your blocks and your connections, and how you can add comments to your connections. Thank you guys for watching. I'm waiting you in the next one. Hello again to everyone. So I'm going to be talking about the different visual style of the events, variables, graphs, functions. So I'm just going to get rid of all of those. Let's say I'm coding out, and I'm going to delete this. So let's just start with this one. The events will always appear red, and they're gonna have this little arrow over here. So just to visually remember them, here at the event graph, the arrow is the same. So events will have red box and will have this arrow. The next thing is the construction scripts. Here, the construction script will have this this little box over here, and this construction script is not deletable, so it will always be here in the construction script section. The next is our macros. Let me add a new macro. So new macro, and if I go to my event graph and if I drag and drop it, our macro will have this M icon and will be gray. So our macros will look like this. Our functions, this is a function, print string, will have a blue color and an F in the top left corner. So it says this is a function. Our multigate is also gray, and you can see a trident over here, which is saying that from this box you can extend a lot of outputs. So basically all the blocks have very good iconography, which is telling you what it does with a simple look. The next thing is the variables. So the first, let's add the first variable, variable 1, and this is a boolean. So if I drop it, it is red, it is rounded, so the variables will be rounded, and the color code will be different for each variable. So if I select integer, change variable type, you see that it looks greenish right now. If I add variable number 2 and let's say a transform, it will be an orange one. So all our variables will have this color range, and they're gonna be rounded like this, so you can easily with just one look know what is a variable, what is a function, what is a macro, what is a multigate, what is an event graph. The next thing is if we add a get function, let's say get distance, the get functions are green, so because they are getting some information and they are returning a value. Because in the print string you can just stop there. So for example, connect event begin play, print string, it says hello dear fellas, end of story. But the get functions, we need something in the target and they will need to return a value from that get function. So those functions will need to be connected to something in order to work, and they're green. So this is pretty important because when you have a pretty complex event graph, you can just visualize everything. So for example, if my graph is pretty big, I can tell from here that this is a function, this is a get function, this is a variable, this is a macro, this is a multigate with different connections. This is pretty handy when you're working with the event graph because all those visual things, when you remember them, you're gonna work faster. So thank you guys for tuning in. I'm waiting you in the next lecture. All right, hello to this lecture. In this lecture, we're gonna talk about variables, and I'm gonna explain all those variables over here, what they does and what you can use them for. So the first one is our Boolean. Our Boolean variable can be true or false. So what this does is you can use the blueprints and the Boolean variable to say that something is true or something is false. And for example, if we have a little door over here and our character move to our door, you can say that this door is still closed. So if our Boolean is is door closed, and before the character entered this zone, for example, this is our collision zone that our door will enter, our Boolean variable will be false. And when our character move over here and trigger the collision, our variable will change to true. So you can use the Boolean variable for example like this to open or close doors, or you can use it for click buttons on the interface. So for example, if we have the start game button, you can have is the game button pressed, it is pressed, then start my level, start level. If my button is not pressed, it is false, don't start my level. So this is pretty much about the Boolean variable and what you can use it for. All right, so the second one is the byte, and the byte is a variable which has a value from -128 to 127 plus. So this is the range in which you can use the byte variable, and it is often used to save memory. So for example, if you want to save memory in large arrays where the memory saving actually matters, you can use the byte variable. All right, this is about the byte variable. The next two is the integer type. So int is our third variable. So this variable always use a whole number. For example, 1, 2, 3, 4, 5, 10, 20, etc. So it uses this range of whole numbers. Integer cannot be 1.1 or 2, 3 or 4, 0, 5. You cannot use those values with integers. So integer, a whole number. The next one is float. So this is like the integer, but it can use decimal point. So float can often be 4.5. It can be 60223, etc. So the float can accept decimal points. That's the idea. Moving on is the name. So name. This variable is a text, but you can use this variable for names of objects that are not oftenly changed. For example, character name, or for example, map name, etc. So you can use the name variable for names that are not oftenly changed. So that's the idea behind the name. Moving on is the string. So what string does is it's the same like the name. You can use different strings, but this is changeable. So for example, our string can be dead, and this can represent the player status in a text format, or alive, which will indicate that our character right now is alive. So you can use string for texts that can be changed. Moving further on with our text variable, this is pretty interesting variable that you can use. So the text format is as follows. So the text variable will be like that. Let's say we have welcome text, and we want to name to say welcome player 1, player 2. We can define this like that, player name, and this player name can be given like a parameter, and every time we have welcome, we can say welcome Mike. If we give Mike parameter to this, we can say welcome Jake. This is changeable, but this will stay the same. So you can use text for this type of actions in your games. All right, vector. This is my favorite. What vector holds, this variable, it holds x, y, and z coordinates of a 3D game. For example, our 3D game has this one, has x, y, and z coordinate system, and this vector is holding the values of this. So for example, if our player is here, let's say our player is here, we can define that the x of the player is 2, and it is placed here. For example, here is like 1, our z is 1, and on y our player is connected to the ground, so our y is 0. So let's say we have a little decimal, and this is a vector. It will be written like that, 5 and 0. So this will be the information that our vector holds. It is the representation of our object in the 3D space. So this is what the vector does. The rotator will be the same, but it will represent the rotation on the different axes. So for example, if we have those axes, so let's say this is our y-axis, this one, this is our x, and this is our z. It will tell Unreal how our object is rotated on y, x, and z. So the last one is transform, which will hold all the properties of our 3D object. So for example, if this is my cube, let's draw it a little faster, and transform will hold all my transformation, like where is it on the axis, like a placement, and it will hold all the rotation axes, and it will hold all the scale axes too. So how big my cube is. So it will hold position, it will hold scale, it will hold rotation. Those are the properties of the transform. This was pretty important lesson. If you have any further question, you can go to Unreal documentation and just read all about those variables. Thank you guys for watching this lecture. I'm waiting you in the next one. Hello again and welcome to this lecture where we're going to talk about and show you integer type, how to connect it and how to summon it in the event graph. So the first thing is I'm going to create a variable and I'm going to call it health. As I mentioned in the previous lesson, integer will be a variable that is positive and negative, but it will have a whole number. It's not containing any decimals. So I'm going to select from the drop down menu here in details, I'm going to select the integer. And right now we have the integer. But before we define the value, we need to compile. Here in the default value, it says, please compile the blueprint. So I click compile. And now we can set up the health of our player. Here in the variable, you have description. So for example, I can say, this is my global health of the player. This is just for information in order to clarify what this variable is used for. The variable names should be unique. You cannot have the same variables with the same name. So if I want to create another health, I need to call it health1 or health2 or whatever. So right now, let's say our player will have 100 health. I'm going to compile again and save. And how we can show this on the screen. I'm just drag and drop my variable and I'm gonna get health. So I need information from this variable is by setting up get health. If I want to set up the health of this variable, I will use set. So I'm just gonna use get. And as you can see here, it is circle with a little arrow. Here is big arrow. And here circle with a little arrow. Everything here is the same. So I can drag and plug it into the string. And what will happen is when I play the scene in Unreal, it will show my health as a text. This block that appears randomly, it's conversion from integer to string. So Unreal is doing this automatically. In other engines or using C++, you need to convert your int to string by code. But here in the event graph, Unreal Engine is doing the magic automatically. So right now, everything is set up. I just compile, save, and when I hit play, I'm gonna have my health here represented as 100. And one very important thing is that this variable is unique and can be used across your event graph everywhere. But keep in mind that if I put here the health and use the get option, or maybe let's use the set option. So right now, if I plug something to set the health here, let's say I want my health to be 20. If I set it up here in my set health to 20, all the health variables across the event graph in this blueprint will have the health 20. So for example, here, if I have a medkit pack, and maybe some logic over here that does some damage to my health and get my health to 20, I can set up, for example, here medkit pack that is setting up my health back to 100, just like that. And my original health will be displayed here as 100. And this is very simple example how you can use it in the event graph. Thank you guys for watching and I'm waiting you in the next video. Alright guys, so let's move with the next variable, which is a float. So let's create one. I'm gonna go to the variables tab, hit plus, and let's say it that timer. So I'm gonna choose from the drop down here, or you can choose from the drop down over here. I'm gonna choose float, and right now the color of the float is green. So this is how I can tell the difference between integer and float. Again, you need to compile in order to activate it and see that it has a decimal over here. So that's the difference between integer and float. Let's say 60.08, like that. And again, if I drag and drop it here and click get that timer, I can connect it over here to the string, just like that. Let's move that a little bit down. Let's select this, delete it. And right now I need to hit compile and save. And if I play my scene, I'm gonna have 60.08. So this was the representation of the float in the game. And right now it is again converting into string. But there is something else. Here is pink. So pink means it's a string. But here at the duration, you see we have 10.0, which is a float. So for example, if I want to set up a dead timer, and if I don't want this duration to always be 10, and if I want to control this duration through some game logic and not to always be 10, I'm gonna connect my dead timer to my duration. So right now my duration will be whatever I put over here. So I can put 15, and after 15 seconds, if I connect the health over here, the health text will disappear. So this is a good best practices in creating game logic, not to have important values hard coded just like this. For example, let's disconnect this. This is like hard coding. Every time that I want to change this value, I need to go back here and I need to change it. But it's pretty hard when you have huge game logic to go and just select this block of functions, and this is not practical at all because you cannot change it through code, through logic based on your gameplay. So what you want to do is you want to create a variable for this, and you want to set it up over here to whatever you like, and you can set it up through code later on. So this is how the logic will work. So right now the print string will have 15 seconds before it gets destroyed. And let me show you a little trick. You can create the variables if you right click over here, not just from clicking over here the plus. If I right click over here, I can promote to variable and I can have duration. It just automatically takes the name. So let's rename this to dead timer duration, just like that. So this is another way how you can create variables just by right clicking on the node. If you click here, you can create another variable. If you click here, you can promote another variable. So we can control the text color, we can control the print screen, we can control the key. Everything that you need to do, you can control them through variables. And this is very flexible, and it's a good practice if you're building a game. This is pretty much about the float, pretty simple. Again, here you have a lot of details that we're gonna tweak later on, but the basics is this about the float. Thank you guys for watching. I'm waiting you in the next video. Alright, so in the previous lesson we've talked about float. Now we're gonna talk about Boolean. Let me just clear up this. And again, from the variables, I'm gonna create Boolean and I'm gonna name it character is dead. And I'm gonna put underscore and bool. And naming it like that, I will know that this variable is Boolean. I'm gonna select the Boolean. And what this does, let me just drag and drop it over here. I'm gonna click get Boolean, just like that. And here for the value, you need again to compile, save. And right now, the Boolean is ultra simple variable, but it is one of the most used variables in creating games. So what it does, it says true or false. That's it. Is my character dead? True. Is my character not dead? False. That's it. So it is like a check. For example, right now, our health of the character is 100. And let's say we fight, and our health goes to -5. So we are dead, and we can make a check. If our health is below 0, you can trigger the Boolean to be true and our character to be dead. So this is pretty simple logic. If the health is below 0, we trigger the Boolean to be true and we connect it to the death event of our character. That is one good example. And when you resurrect your character, you set up simply the flag to false. saying that our character is not dead. Let me show you with the print string. If I connect it to the print screen, just like that, red to red, this is Boolean. Right now, when the Boolean is false, it's not gonna show the health on the screen, the 100 health on the screen. It's not gonna show it. Let me show you. Let's start the scene. Nothing is showing here. But if I turn the Boolean on to true, compile, save, hit play, I got my health back over here, the 100 health. So this is pretty simple example that I give you with the character is dead or it's not dead. You can apply this for everything. Like, for example, is the character on an elevator? You can say, all right, our character is on the elevator. It's true. Let's play the animation of lifting up the elevator up. And when the elevator is up, we can set up the Boolean to be false and everything works. So that's pretty much about the Boolean. You can set it up to true or false to test and to set up different actions in your game. Thank you guys for watching, and I'll see you in the next one. Alright, so welcome to this video. In this video, we're going to be covering the next variable, which is the vector one. So let's create one. Again, from the variables menu, just click plus. And let's call it vector1. So now we need to select the type of the variable. Click here, click on the vector. And right now, again, we need to compile in order to get the default values of our vector. Click compile, click save. And right now we have 3 values. And what those values are, vector is representing the X, Y, and Z axis in our 3D engine. So here I can say, for example, if I have a saving checkpoint in my game, I can store the player's location on each checkpoint. For example, if the saving checkpoint is 10x, 0y, and 30 on Z, and this is the place where my player checkpoint is, and there I need to revive him when he dies. I need to revive him on this position. I can save him on this variable. So I'm just gonna drag and drop it, get vector, and see that yellowish color. So when a variable is yellow, you're gonna be knowing that this is a vector. So this is one example of what you can use the vector for, but primarily this is representing the axis, the X, Y, and Z. Here in the bottom, you can see the axis in the 3D space. And this is pretty much what vector does. It stores those values and you can play with it, you can call it. And let me just connect it to the string so we can print it. I'm just gonna connect here, and again, it's gonna convert from vector to string automatically. I'm gonna compile, I'm gonna click save, and then I'm gonna click play. And we can see our X, Y, and Z here printed on the screen. So this is the basic explanation of vector. And as I've give you this example of the checkpoint of position of the player where it should spawn when he dies, this is one fairly simple example, but you can use this vector variable in a lot of different cases. Thank you for watching this video. I'm waiting you in the next one. The next variable that we're going to talk about is the rotator. So I'm just going to go straight to the point and create one from the variables tab. I'm going to click plus. I'm going to call it rotator1. And as you can see from this drop-down menu, I'm going to select rotator and the color will be blue. I'm going to drag and drop it here in my event graph. And we can see bluish color for the rotator. Again, we need to compile the blueprint in order to get the values, compile, save, and we have the same values X, Y, and Z. But those X, Y, and Z values are for the rotation of our object. So let me just create one cube pretty fast to show you what it is. Let me just go to my details. So the first thing is the location. When I'm moving my cube, you can see the green axis is changing, the blue axis is changing, and the red axis is changing. So this is our vector from the previous video, and this is our rotator. they both have the same values x, y, and z. But for the rotation, it is called the x is roll, which is this. It is rolling. The y is pitch, which is in this direction. And the z is yaw. So it is rotating from the base. So it is the same like the vector, but you have those three x, y, and z just for the rotation. And if you wonder which is r, p, and y, it is the roll, pitch, and yaw. And I'm going to show you why I'm telling you about the roll, pitch, and yaw. I'm just going to go here and I'm just going to connect it to the string. I'm going to delete this vector. And as you can see, it's converting the rotator to string. I'm going to compile and save. And I'm going to play my scene. And you see we have P, Y, and R. So this is the things that I've mentioned to you about pitch, yaw, and roll. So it is representing the values of x, y, and z with the roll, pitch, and yaw. So you know that this is a rotator and it's not a vector. So this is the difference between rotator and vector. Rotator is simply for the rotation of your object, and vector is for your transformation of the object. So this is about the rotator. Thank you guys for watching this video, and I'm going to be seeing you in the next one. Alright, so let's continue with the next variables that we're going to talk about. I'm going to be covering three different variables, the name, the text, and the string at the same time, because they're pretty much similar to their core. So here from the variables plus sign, I'm going to add three new variables. String 1, let's do one text 1, and the last one, name 1. Alright. I'm going to change the type of the variables. So the first one is a string, the pink one. The second one is text, which is this one. And finally, we need a name. All right, so let me just drag them over here and use the get function from there, just like that. All right, and as you already know from the previous variables, we need to compile and save, and let's start describing each one of them. So as you see, the string is pink, text is a little bit more of a pale color, and the name is purple. So what's the difference? If I click on string, I have a field where I can type different strings. If I click on text, I have the same field, and if I click on name, I have a little name. So what's the difference between those three? Let's talk about the text first. So the text is pretty much self-explanatory. Here you can store huge text data. For example, let's say a conversation or a text from a note. The next thing is the string. For the string, you can use different strings, like for example, if you want to put player health, just the word health, like that, health. And later on, if you want to localize your game in different languages, for example, German or let's say Japanese, you can use this string value, read the health, and translate it into the language that you desire. The string is often used to represent, let's say health, mana, or stuff like that, a little bit short words that you can use in your game as information what different things are. And the final one, the name, I often use the name for character names or sword names. For example, if my character is called Mike and it's not changeable, I just keep this name over here and assign it to this variable Mike. And let's say we have a dark sword, and this is the name of a sword that we have in the game. So I often used the name. This string is not often changeable in my game, and it's keep having this name. So this is pretty much about those three different components, and of course you can plug them in here. It will convert the text to a string. This is a string, so it will not require conversion. And this is a name, So this name, you can place it here in the key value. Here in the print string, you can see different colors that are connected here. So this is pretty much about those three different types of text string name. Thank you guys for watching, and I'm waiting you in the next video. Alright, so from the previous lesson, we already know what string it is. So we're going to continue on, and I'm going to show you a few functions that can manipulate this string. So we have the string over here, the string 1, and I just delete the other blocks and the other variables, and I'm going to create string number 2. And I'm going to place it on the graph, get string, and I'm going to hit compile and save. I'm going to go in my first string, and I just named it Mortal, and the second one, I'm going to name it Combat. All right. Keep in mind that you need to select here string and string. Don't forget about these guys. And the first thing is how you can connect those two strings. So I'm going to select this, just drag over here in the event graph with my left mouse button, and I'm going to just release. And I'm going to type here in the search append string. And you need to have this utility strings. So to verify that append is for string, it needs to be under the string section. So I'm going to click here. And what this function does, it's connect the input of A and the input of B, and just return a value by connecting those two strings. So I'm going to connect this over here, and the return value, I'm going to connect it into the string. So right now I'm going to hit compile, save, and it's going to place a text Mortal Combat, and it's going to connect those two texts. And I want to have space between Mortal and between Combat. So here in Mortal, I'm going to just put a little space over here, one space bar. I'm going to compile again, save, and let's see the result. I'm going to hit play, and it says Mortal Combat. So this is how you can connect two different strings into one and type it into a print string. So this is the first function, append string. And what it does, it connects two strings. All right, let me just delete it. And let me show you a second function, which is to upper. And you need to select the one under the string here. And this will just create your string with upper cases. So mine right now is Mortal, the M is capital, the rest is lower cases. I'm going to compile, save, go, minimize it, hit play. We have Mortal with upper cases. Fine. This is another function that you can use in order to make your text to upper cases. And of course, you can use the other one to lower cases, connect it over here, compile, save to lower cases. And now my M will be with a lower case. This is pretty handy when you want to manipulate your text with these functions. Let's go with another one where you can compare two texts. So I'm gonna right click, and I'm gonna type equal, and I'm gonna search for equal exactly for the string here under the string section, equal exactly. And right now, if I input here in the first one and the second one, my text is not equal. So the first one is Mortal with a space bar, and the second one is Combat. And when I plug it into the string, it creates the conversion right here. It will say false, that my first string is not equal to my second string. So it says false. And then let me just put Mortal onto the second string. Mortal, let's remove this space bar. I'm going to place it over here, compile, save, let's go, minimize, and let's see, it says true, so perfect. This operator is just comparing the two strings, and it's giving you a result, true or false for it. And let me explain one more, which is the contains. So we are searching again under the string contains. This is pretty self-explanatory. So I'm just gonna connect the first string to my first search in, and in the second one I'm gonna type the word that I want to search for. So I want to search for Mortal, and I'm gonna return the value. Again, it will say true or false, that if this string contains mortal or if it doesn't. So I'm gonna hit play and it says true. So this string is containing the word mortal, and this is how you can compare and search for words in string. And of course, I can connect here another string that I can manipulate and not just hard code it over here, the word that I'm searching for. Let's say combat. And you also can use the case sensitive option. This will search with the case sensitive if you have upper and lower cases, and it will search for exactly the same word. So for example, if I did not check the use case, I can type mortal with a capital, and if I hit play, it's going to return true because the word is the same, but I'm not searching for the sensitive case words. And if I turn it on, compile, save, and hit play, now it will return false because one is with capital and the other one is not with capital letters. So this is how you can search inside your string for exactly the same words, if it contains them or it doesn't. Pretty much those are some of the basics functions that you can manipulate text with. If you want to search for more, there are a lot of more functions. For example, if I right click here, type string, I can scroll down and this is the string category, and you can see that we have a lot of functions to choose from. So this is pretty much about basics of the functions for the string. Thank you guys for watching, and I'm waiting you in the next video. Okay guys, so in the previous video we talked about strings and how we can manipulate them through functions, and I'm just gonna get rid of those that we've created. I'm just gonna leave this duration, and I'm gonna create two integers. So the first one is health. Let me just put it over here, and I'm gonna create new one which I'm gonna call armor. All right, and I'm gonna choose to be integer, and I'm gonna place it over here, get. Remember, you need to compile, save, and I'm gonna set up my health to be 100 and my armor to be 50. Or let's say something pretty low, like 10 and 5. And I'm gonna show you how you can create some basic mathematics out of there. So let's drag from the health over here. Let's drop it over here and just press plus on your keyboard. So this is the operation for adding, and I'm gonna click on add. And what we need to do is we need to connect the other value that we want to add to. So I'm gonna add this, and what this does, it's gonna add 10 plus 5, and let's render it and place it on the screen with this string. Let's play our level, and we have 15. So this is the first operation that we can do. We can add one number to another, and here from the add pin you can add as many as you want points to be connected, so you can add a lot more numbers over here. For example, if we add here 10 more, let's say 10 more, 10, we're gonna add 30 to those 15, and it's gonna be 45. All right, so this is the first function to add a number to another number. Let me just delete this. Let me show you the second function, how to divide. Just drag and drop over here, click minus on your keyboard, or just type subtract, and you can use this operator. Click here, and right now from 10 I'm going to subtract 5. I'm going to connect here, compile, save, let's run it. We have 5, so 10 minus 5, we have 5. Great. So this is our subtract. Again, you can add different pins over here, pretty easy. Let me delete this one too. So we know how to add, we know how to subtract. Let me show you how to multiply. Right click, multiply. So this operator multiply, and now we're gonna multiply 5 by 10, and we're gonna have 50. Let's compile and save. Let's play and we have 50 over here. All right, pretty good. You can add another, let's say 2. Let's split, and we're gonna have 100. So this is how you multiply two numbers, by using this multiply operator. And the next one is how to divide. And here in the operators, click divide. I'm gonna divide 5 by 10. I'm gonna click compile save, and it's 2. All right, and let me show you a little trick. So we're working with whole numbers right now. So if you have not an even number, you need to use the float. So there is divide, but there is divide for the float. So this will divide two numbers, two float numbers. For example, if I want to put two float numbers, I can divide this to this one, and it will return a value with a decimal point. So this is how you can divide float numbers. So the last example I want to give you is I want to show you how you can divide with a decimal point. I'm just gonna delete this one, and I'm just gonna drag and drop this float over here, and this is 20, and I'm gonna drag and drop over here. I'm gonna type divide, and I'm gonna use save divide. So right now we have 20, and let's say we have 21.5, and I want to divide it by 2, and I'm using a float divider. You can see that this is green. All right, and if I play now my level, it will show 10.75. So this is how you can divide numbers with decimal points. So those are very pretty basic mathematics that you can do here, but this is something very useful that we're gonna use often. Simple operations like add, multiply, divide, etc. Thank you guys for tuning in into this video, and I'm waiting you in the next one. Hello again, guys. So in this video, I'm gonna be talking about some comparison between two values. So in this video, we're gonna be covering if one value is equal to another value, or they are bigger, smaller, or bigger and equal or not equal. So let's just start. I'm gonna drop the health here. I'm gonna put get. I'm gonna drop the armor. I'm gonna put get. So right now my health and armor are equal. I'm gonna make my armor 5, and we're gonna start with the first operator, which is I'm gonna right click here and just put this symbol, which means greater, or you can type just greater, and you need to search under operators. So right now I'm gonna connect my health over here, my armor over here, and I'm gonna print it in the string over there. So right now what this operator will do is it will compare if my health is greater than my armor, which is 5, and it should say yes. Let's try it. So it says true, so my health is greater than my armor. This is the first operator which you can use, greater. The next one is less, which will be defined by this bracket, or you can just type less. And now I'm gonna connect my health and armor. Again, I'm gonna connect it to the string, and let's see what it does. Is 10 less than 5? No, it is not, so it gives us the result of false. All right, moving on with the next one. You can also define less or equal, which is this one, operator less or equal. All right, I'm gonna drop it over here, and right now I'm gonna connect those two. And right now what this operator will does is this 10 less than 5? If it does, it will return us true. And the other condition is this 10 equal to 5, which is false. In this condition, if 1 is met, it will give us the true result. So for example, let's say this is 10 and this is 10. So the first condition will be, is this less than the armor, which is false. But the second one also checks for, is this equal to the armor? And if this is equal, it will give us true. So right now we're gonna have the true result right here. All right. So this is the other condition that you can use, less or equal. And of course we have greater or equal, this one. It will be the same as the previous one. And there is one more, not equal, under operators, not equal, which will compare if the first one, the health, is not equal to the armor. Right now they're equal. We have both on tens, so it will say false, they're equal. And if I change my health to 5, compile, save, hit play, they're not equal. So those are some of the conditions that you can use in order to compare two values. We're going to use those very often, so you're going to need to master them. Thank you guys for tuning in. I'm waiting you in the next one. Hello everyone and welcome back to this part. In this part I'm gonna explain what is get and set for our variables. So let's just drop this one, and from our previous videos we only use the get armor, just this function. But there is one more which is set, and we have a different block over here. So the first one is the get, is just to get the value that we've already set up. And we can connect and we can represent this. But the set value will set this variable. And right now I'm going to just disconnect this, the print string, and I'm going to connect my event begin play to my set value. I'm going to connect to the print string, and I'm just going to connect my armor over here in order to print it up. I'm going to add here a little note just to clean it up. And right now with this setup, what the flow of the game will does is we start the game here at event begin play. We set the variable. It doesn't matter that we have 10 here, because the game will set a new variable over here to our armor, and then we're gonna print the new variable that we've set here. So let's set 2. Here we have 10, but this is the default value, and we are changing this value when we hit the play button of our game. With this set function over here, with this set block, we are telling that our armor will be 2. So I'm just compiling, saving, and here we're going to have the new number set up. So what this does is it is setting up this value before we printing it. And if we reverse this, let me just disconnect this, and let's connect this to the print string and connect the print string to the set. Right now the flow is different, and what we'll do is we will start the game, we will print the string. This armor is not set before we get into the print string. It is set after this function is executed. So let me show you the flow. Right now it will show us 10 over here. Again, I want to repeat. We start the game, we execute the print string function. The armor is still not changed because our set is over here, and we have 10 armor. But if we add another print string over here and we set up this, and let me just copy and paste this over here with Control C, compile and save. Now we have 2 and 10. So the first one is 10 and the second one is 2. So the flow changes the value. The first one, we are printing the original value, which is 10. And for the second print string, we are setting up the value to be 2. And we are connecting the same value and just printing it out over here. Let me just increase the duration, compile, save, hit play. And as you can see, we have our first value here, the 10. Thank you for watching this part. I'm waiting you in the next one. Alright, so in this lesson I'm going to show you how you can make your variables public and private. This is very useful in order if you want to use some variables from one blueprint to another blueprint. So let me show you how it works. So here I just selected my armor variable, and from this panel you have private. Right now this variable is public. What this means is it is public to all the blueprint classes. So I'm just gonna quickly show you how you can access it from here. from the list drop down of the blueprints, you can open the level blueprint. And this is blueprint for the map. And here I can right click here and type reference and just go all the way to the top. So I can create a reference to blueprint, first blueprints, which was the original blueprint that we are working on. And by creating a reference, I can access their variables. So I'm just gonna drag over here and just type health. So I want to get the health. And right now in my new map blueprint, I have called first blueprint class, and I also get the value from this health status. So in this blueprint, I get this health integer. And this is how you can access different variables from different blueprints. And let me show you another example. This is my original blueprint. I'm gonna right click and create a child of this blueprint and call it BP child. All right, when I double click, I have a clean blueprint class. So I go to event graph, I'm gonna right click and I'm gonna type health. And as you can see, I have a variable get health. And this variable health is from my original blueprint, first blueprints class. So what this does is I'm creating this child which inherits the variables from its parent. So this is another way that you can access your variables. But let me change this to private. I'm going to delete this, compile. I'm going to select my health. I'm going to click on private, compile, save. Go here and let's try health. And right now I don't see my health because I set up the variable to be private. When you set up the variable to be private, it will be only included in this blueprint. And now in my new map, if I drag over here, type health, you see that I don't have this variable available because I've changed its status to private. However, I still got my armor, and my armor by default is public. So this is just brief explanation on how you can call your variables from different blueprints. We're going to explain this in details in the following videos. So thank you guys for watching this one, and I see you in the next one. Hello to everyone. In this video, I'm going to show you how you can access your variables in your scene. Right now, when you need to change a variable, you need to open the blueprint and set up your armor to 100, for example, compile and save. But how can we just select this object and here from the details panel, just set up our armor, and how we can bypass to double click here to find the variables over here and to set up the default value. So there is an easy checkbox. So you need to check here, instance editable. Just click here, compile and save. And now when you select your blueprint in your scene, we can go to default and you can see this is the armor that we set up. I can set up 50 and this blueprint will have this armor value to 50. And let me show you another quick tip. If I click on this armor variable, there is a category, and here I can type, let's say this is my armor category, and this variable is going into the armor, or let's say player stats, and I'm gonna put my health here also. So under the player stats, I'm gonna have health and armor, and I'm gonna expose my health also outside of this blueprint. Keep in mind that this is instance. So what this means is when I place here, let's say 150, this will be only for this instance that is spawning over here. So as you can see right here at the player stats, I have my health and I have my armor over there. So it's easy for me to be adjustable. Let's say I want to change this player stats. I go here, set it 80, set it 100, and it's done. I'm not going to get over here and just start changing all the values over here. Keep in mind that this is an instance editable. What this means is when you drag and drop your blueprint over here, you can adjust those settings only for this instance. So if I drop another instance, it will have the default value that I've set up in my blueprint. And I can set up here 2050, and this will have 2050, 20 health, 50 armor, and this one will have 80 health and 100 armor. And this is an easy way. For example, if you spawn those blueprints with a code, you can easily set up different player stats over here. So this is pretty much how you can get your variables outside of the blueprint, and how you can create the category player stats and organize everything to be very readable and to work very good. Thank you guys for watching this one. I see you in the next one. All right, so previously we've talked about how to expose the variables, and right now I'm going to show you how you can spawn your actor without dragging it from here over here, just like that. And we have this BP first blueprint. I'm going to show you how you can spawn this with actually blueprints and code behind it. So the first thing that you need to do is go over here in the list of the blueprints and open level blueprint. All right, so this is the blueprint for the level that we have over here. Let me just go back to it. And right now I'm gonna right click here and I'm gonna do spawn, and I'm gonna choose spawn actor from class. What this does, it's gonna spawn the actor from our previous class, but we need to do some adjustments. In the previous blueprint, we're gonna select the health and we're gonna select expose or spawn. I'm gonna select this. So those variables will be exposed when you spawn your actor through this function, spawn actor. I'm gonna compile and save. And right now, I'm gonna compile over here, save. And I'm gonna select my class over here. Just type BP first blueprints. And when you select it, you see you have your two variables over here. So what this does is when you spawn the actor, I can change the health to the current spawning. Let's say 3200. And right now I'm spawning my class, which is blueprint first blueprint. I'm gonna spawn it at some location, and it's gonna have this health and armor. For this case, I'm gonna need to create a variable, which is spawning position, and it needs to be from the transform type. And I'm gonna drag and drop it, get the spawning position, and I can define, let me compile, I can define a spawning position for this one or scale, but I'm just gonna connect it over here and it's gonna spawn on 0, 0, 0. And the next step, of course, when the game starts, we need to do this action to spawn the blueprint actor. And one final step, in order to have a better look on this, let me just show you what it happens. See here in the outliner, when I hit play, we have this BP first blueprint spawned, and we have the health 30 and 200. So we define this in the level spawning over here. In the level blueprint, we define this over here, but we actually cannot see where our BP class is. So I'm just gonna go to add over here, and I'm just gonna select a cube. This is just to visualize where the object is spawning. And let's hit play. Let's look around. And here's my cube. So this is the cube that I've spawned over here. And those are the values. 30, 200, and this is the cube. So pretty neat, guys, to spawn actors with blueprints and not with drag and drop like before. I'm just gonna delete this one, and this is the function. And if you want more variables to be exposed over here, you need to go to your original blueprint, select editable, and then select expose on spawn. This you need to check both of these in order to have them over here. Compile, save. So this is how you can spawn actors through blueprints. I hope you learned something, and I'm waiting you in the next video. Hello everyone and welcome back to this next video. In this video we're gonna start talking about arrays in Unreal Engine, but first I need to make a short brief in theory what array is. So let me just, for example, create 5 different red circles, 4, 5, and I'm gonna create 5 different green circles, just like this. So we have those 5 over here and 5 over there. So basically array is sequence of elements in specific order. And for example, let's take the red one. So we have 1, 2, 3, 4, 5 different circles, and this is an array of circle. The first thing that we need to know is that array has a type. So array can be array from integers, array from floats, array from bools, etc. So what this means is that this red array up here, if it's array of ints, this one, it can contain only integers. So it can contain only type of the array that we define. So all those must be numbers. For example, this position is 1, this is 3, let's say this is 10, let's say this is 30, 32. So this is an array of 5 elements that holds those numbers over here. All right, because our type is int. You can have a float, you can have a bool array, and there is a specific one which is called object array, and it can contain objects, and objects can be different type of objects, but we're going to talk about this later on. So the next thing that is super important, that array has indexes. So the first element in our array starts with 0, the second one is 1, this is 2, this is 3, and this is 4. And why an array has indexes and starts from 0? It starts from 0 because this is how in programming work. Keep this in mind that all the arrays start with 0. And why do we have these numeric values connected with each? Because when we call an element from our array, we said we are calling our red integer array, and we are calling element number 2. And in element number 2, we have 10. So that's how you search and call functions from the array. So you call the array, the type of the array in integers, and we call element number 2, and under element number 2 we have 10. So we get data based on indexes. All right, the other thing that you should keep in mind is if we have 1, 2, 3, 4, 5 red balls, and we have 1, 2, 3, 4, 5 green ones, you cannot transfer the data from this one to this one. Let's say this is an int array, all right, and let's say this is a string array. All right, they have different type, string and int, and you cannot, this red object cannot be transferred over here. What you need to do is you need to have 4, 5, 1, 2, 3, 4, 5. You need to have arrays of the same type so that you can communicate with them, so that you can transfer data. If we have this string array, and here if we have again string array, we can transfer data. So this one can go here, this one can go here, etc. So this is the basic of how you can communicate with an array. And of course, if you have two arrays of type object, you can transfer data between those two. So in order to summarize, the first thing is that arrays has a type, in this case integer, it can be whatever else you want, float, bools, string, name, etc. The second thing is array hold under an index different type of data, and if you want to access this data, to get the data, you first need to call the array and then call the index that you want the data from. All right, and the third thing, you can have arrays of type objects which are more flexible, and they can transfer any kind of data to another array of type object. The final thing is that you cannot transfer data from different type of arrays, like this one is int, this one is string, you cannot transfer the data from one to another. All right, you can't transfer data from the same type of arrays, just like that, string, string. All right. So in the next video, you can have more clear picture of how this works. Thank you guys for watching. I'm waiting you in the next one. All right, welcome back. So in the previous video, I've talked about briefly what array is, and now we're gonna create array in Unreal Engine. So I'm in my blueprint, and here from the variables, I'm gonna create array bool. And here in the top right, you can see next to the variable type, we see a drop down over here, and we can set it up to be an array. Right now, it is set up to be a variable. So click here on this arrow and click on array. So right now is single, which means single variable. When we click here, we have a little squares over here showing that this is array. Just click on this and it will be automatically transferred to an array. But what you need to do, of course, compile, save. And right now we have arrays of bool elements. Here in the default value, we can add different indexes. And as I've mentioned, you see here, it starts from 0 until 6. From this drop down, you can insert a new element between those two. So if I click insert, it will insert one more over here and it will take the index of the previous one. You can also delete or you can duplicate, just like that. So let me show you. If I click here, true, duplicate, it will create one more with the true value. Let me delete it. It's gonna delete it. Also, you can rearrange from here with that a little snippet. You can place it under another index. As you can see, I'm just moving it and it's pretty easy. You have also an arrow showing which is the order where it will go. It will go beneath or above. Let me show you like that. All right, beneath 1, above 3. So this is how you create an array. Let me just drag and drop it over here, get array. And you see here in our event graph, it's a little bit different, this boolean. Let me just change this string to normal boolean. Let me just drag and drop it. So the difference between those two is that the single boolean has this circle over here, and you can see that our array has this a little square over here. And this is how you can create an array of type boolean. Let me create one more array int, and I'm gonna select integer. Again, I'm gonna go here, click on array, click compile, save, add few indexes, and I can add different values, just like that. 18, 19. Let me just drag and drop it over here. And we have another array, which is with ints. Let me create one more. You get the idea. Let's create with string. Let's name it array string. All right, here is a string array. I'm gonna compile them. I'm gonna save, and I'm gonna add some names: Mike, Zep, Pete, Macro, and let's say Louis. So we have now a string array. Drag and drop it over here, and they all have the same square over here, but they are different type of arrays. So if you want, for example, to access Zep, you need to access the index number 1 in array string. This is the way how you can create different types of arrays in your blueprint. Thank you guys for watching this one, and I'm waiting you in the next one. Hello and welcome back to the next video. In the previous video, I showed you how you can create an array. Now I'm going to show you how you can get the data from this array. So I've just dropped my array string with all the names over here. I'm just going to select this, the square, and I'm just going to drag and drop here on the grid. And I'm going to type get. What I need to do is I need to get a reference, this one, get a ref. I'm going to select it. And right now, this function will search in the array and give me the result. I'm going to connect it to the string value over here. And here in the dimension, the second one, you see that the number is 0. So what this block get is doing, it is calling the first one, the index number 1, Mike, and type it on the screen. So let me compile and save. Let me just run it out. And we see that we get Mike from this array. Let's just try a different index. Let's say number 3, macro. Number 3, compile, save, play, macro. So it's pretty straightforward. This block is getting the data from the index that you want. Right now it's 3. Of course, we can create a variable, let's say get string data int, and I'm gonna create it like integer. I'm gonna make it like single one. I'm gonna drag and drop it over here, and let's make it editable, and let's keep this public. I'm gonna connect it over here. So right now I can control what I need to get from the array from this integer. So let's say I want to get the index number 1, which is zep, compile, save, and let's run it. Zep, all right. And let me show you a little trick. Let's go to the get string data, and let's click on expose on spawn, compile and save. And right now I'm gonna go back to my open level blueprint, and I still have my spawning position and my spawning actor. But right now what I did is from the spawning actor I exposed the get string data, and here I can change it, for example, to number 4. Compile. Let's go here and just check what number 4 is. It's Louis. And right now when my actor spawns, my blueprint spawns on my level, I can have Louis. Or if you don't have this spawner actor, you can just drag and drop your blueprint here, and you can change this from here. Let's say 0. I can then play, and I'm gonna have Mike and Louis. Louis is because I spawn one actor with this one, and Mike is because I drag and drop this blueprint over here, which is getting the index number 0. So this is pretty much how you can get data from different arrays. Of course, it can be different than string, it can be integer, float, etc. Also, if you hover on this array, you can see all the elements inside that you've hard-coded right now. Thank you guys for watching this one, and I'm waiting you in the next one. Hello everyone and welcome back. So in the previous lesson we've talked about get function, how you can get a specific number of this array. But for example, if you want to find something in this array, so in this array we have 5 indexes with different names: Max, Zep, Pete, Macro and Louis. Let's say, for example, that we want to see if this array contains Louis, and we need to know on which index Louis it is. So I'm just gonna delete those 2 things, and I'm just gonna drag and drop over here, and I'm just gonna type find, and under array find item. Now I'm gonna connect to my string so that I can print into my game the final result. And now here in the second checkbox, I'm just gonna drag and drop this string. I'm gonna get the get position, and here in the string I've typed Louis. But let's try a different one. Let's try Zep. I'm gonna copy and paste this. And right now what this block will do is this block will search in this array, in those indexes, and will try to find Zep in it, and will give us the result on which index Zep it is. So right now it should be on index 1, and I'm gonna play it, and it will show us index 1. All right, let's try and move Zep to index 4. Compile, save, play, index number 4. So it always finds where Zep is going. But let's try Zepton. So it's different and it does not contain in this array. What it will return to us? It will return to us -1. So this is the result -1, which tells us that this array does not contain the item that we are seeking for. So in that way, when this function find gives you -1, you can do some logic on it that you didn't find this element. Maybe it's not available on the market or in your player's inventory, etc. So this is about the find element. You can find different types of variables here. Of course, if it was integer, you can find a specific number in the array. But right now we were searching for strings. Of course, you can skip the step to connect a string and just type here directly zep. It will work too. Let me show you. Index number 4. So this is pretty much about the find element. Thank you for watching. I see you in the next one. All right, so we talk about get and find. And the next thing that I want to show you is how you can find the length of the array. So right now my array contains 5 elements over here, but how we can find how many indexes this array has. So I'm just going to drag and drop over here, and I'm going to search for length. And this block will give us how many indexes, how many elements this array has. So I'm just gonna connect it to my string over here. Just gonna delete this conversion, compile, save, and it should says 5. All right, our block has 5. So a little example of this is, for example, if you have an in-game marketplace where you sell swords, shields, etc. And let's say here this array holds 5 different type of shields. You can just search the array and find that 5 items are listed on the marketplace. Or you can, for example, have a character inventory and you need to know how many items are in the inventory. You can find it by using the block length. Thank you guys for watching this one. I see you in the next one. Hello again. So in the previous video, we talked about the length of the array. Now we're going to talk about how you can find the last index of your array. I'm just going to drag and drop, and I'm going to type index and last index. I'm going to connect it to my print string over here. Let me just move this block a little bit over here to my print string. And right now what this does is it finds the last element, so it's number 4. We have 4 indexes in our array, and it will give us that information on the screen. So we have 4. Why all these are important? Because right now we feed the data into this array of strings manually, but most of the games and most of the time when we are creating games, this array will be empty, just like this. And we will add elements on the fly. So when your character moves in an environment, and for example, your inventory is empty and you collect a sword, you collect one sword, then you collect a shield, then you collect, let's say, boots, and you collect gloves. Those are added dynamically in the game, and you don't know how many indexes or how many items this player got on the fly. So what we use is we use the get, find, length, and last index to know those dynamic changes in our arrays. So right now our index is 3, and when we use those blocks to make our logic, we use them simply because this array will be fed in real time during your gameplay. Thank you for watching. I'm waiting you in the next video. Hello again. Let's continue with the next very important block. Let me just move my print screen over here, and let me just organize this a little bit better. Just like that. See, it looks good. Let me delete my armor. So the next one is contains item. What this does, it's gonna search our array for an item that this array contains. For example, let's say our character walks in environment and finds 50 HP potion. All right, and we have now 50 HP potion in our inventory. And let's say we need to drink this. So with this contain element, we start searching our array if we have health potions, and then if it says true, we have a health potion, you can drink the health potion and get his health back up to 100, for example. And right now, here in this contains, I'm gonna type in this variable 50 HP potion. I'm gonna compile, save. Let's make this a little bit more beautiful. Compile, save, and it will say, yeah, we have a health potion, and then we can execute the next logic, for example, to drink it, etc. But if we search, for example, for 20 mana potion, compile, save, and we need this mana for a spell, it will says false, we don't have any mana potions, so you cannot rejuvenate your mana. Of course, you can hook up a string over here and just control it outside of this block. Thank you guys for watching, and I see you in the next one. Okay, so we covered get, find, length, last index, and contains. But let's say we want to inject another item into our array. Let me just 50 HP, just add few items to our array. 20 HP, let's say 30 HP, and let's say 10 HP potion. Let's add potion to all those, just like that. So right now we have 50 HP potion, 25, 30, and 10. And let's say we want to insert a 100 HP potion that will rejuvenate 100% of our health if our character has 100 HP. I'm just gonna drag and drop and gonna try to find insert, array insert. And what this does, it will insert an element. Let's say here we want to add 100 HP potion, and we want to insert our element under the index number 1, or let's say number 3. And right now what is going to happen in number 3, we'll insert HP potion 100. But here we have executable links, so it needs to be executed by an event, and we're gonna select the start event over here. I'm just gonna delete this node. So the flow is like that. Let me just get rid of those two. The flow is like that. When the game begins, it will insert this 100 HP potion into our array under the index number 3, and then we're gonna print our string. But in order to print our string, we will need a get function, and we will get from number 3, where we insert the 100 HP potion, and we're gonna print it on the screen. And right now it should say 100 HP potion. All right, and let me just make another print string, and I'm gonna make a new connection over here. So what this will do is it's gonna print our 100 HP potion, and then we're gonna see the length of our array. So right now our array has 4 indexes, and when we insert this one, it will have one more. Let me just compile and save. Let me just play it. We have 100 HP potion and 5 variables in our array. All right, and if we want to check our last index, I'm just gonna connect it over here, and our last index should be number 4 with this one added. Number 4, 100 HP potion. All right, so this is pretty much how you can insert a new item in your array. And we've inserted 100 HP potion into our array. Thank you guys for watching, and I'm waiting you in the next one. So now we know how to insert elements in our array, and now the question is how we can remove elements from our array. So I'm going to show you 2 methods of removing indexes and elements from the array. I'm going to drag and drop here, and I'm going to click remove. The first one is remove index, and the second one is remove item. I'm gonna place those two, remove. Again, they need to be executed on event begin play. I'm gonna connect event begin play to remove index, and I'm gonna connect it to the print string. I'm gonna just break this connection. And right now, remove index, we remove the index 0, this one. And let's get the index 0. If it was not removed, it should set 50 HP potion in the print string. But now when we remove the index, it will say 20 HP potion because all those three elements are moving upwards and we have only 0, 1, and 2, which will be represented by 25, 30, and 10. And this one will be removed in runtime. So let me just demonstrate this. 25 HP potion, and the other one is removed. The 50 HP potion is removed. All right. This is how you can remove an element by index. So if we type here index number 2, it's going to remove index number 2. Let me just connect it to the other one. Let me disconnect over here. Here you can remove item by its name. All right. If we want to remove HP potion 30, we just type here 30 HP potion, which is under the index number 2. Let's get index number 2. Let's compile, save. Let's hit play. 10 HP potion. And why we have 10 HP potion? Because index number 3 is moving in the index number 2 position because we remove index number 2. So this is how you can remove items from this array, especially strings. Right now we're working with it, but you can of course use integer, etc. This is how to remove item by name by using this function. Or if you want to remove item by index, you also have this option by selecting remove index. Thank you guys for watching this one. Let's continue in the next one. So we know now how to remove elements by index or by name, but how we can clear the whole array. Let me show you. There is a quick clear function, and let me just connect it over here. It does what it says. It will clear the whole information in this array. I'm gonna connect it over here, and let's try to find the length of the array, and it will show. Right now we have 4 elements. It will show that we have 0 elements. Let me just play it, and it will say 0 over here. Great. So this is pretty handy. For example, if you have a character which has inventory, and in this inventory array we have swords, boots, gloves, etc. And you got killed and you need to clear this inventory and drop it on the ground. With this function clear, you can instantly clear everything that he holds and he will lose it and maybe spawn it in the position where he dies. So this is pretty handy function to use on. Thank you guys for watching, and I'm waiting you in the next one to continue learning Unreal Engine 5. Hello and welcome back. In the previous video we talked about how to clear the whole array. Now I'm going to show you how you can combine 2 arrays together. So let me just drag and drop over here and just type array. Here you can find the whole list of functions for the array. You can find item, you can clear, you can add unique item, you can insert item, you can check if the array is empty, it is not empty, you can check if one index is valid. Let's say it is not destroyed. You can get random from arrays, etc. You can reverse the array, you can resize it, you can shuffle the array. Here are a lot of handy functions, but right now I want to show you append array. The rest you can read about in the documentation. I cannot cover everything, I'm just covering the most important. So let's select append. What this does, it will combine 2 arrays together. So again, I'm gonna connect event begin play, and I'm gonna connect it to the print string. And here I've connected length. So I want to show you what is the length of the array. So right now our array has 4 elements over here, and here we need to connect another array here, or we cannot compile this blueprint. So I'm gonna create a new array and call it array string number 2. I'm gonna drag and drop it over here, get array, and I'm just gonna connect it over here. Right now, we don't have any elements over here to add to the previous one. So it will say we have 4 elements in total in the 2 arrays that we have. But here, if I add 3 more and I call them sword, gloves, and helmet, if I compile and save, let's say you would a player and you find 3 more items, sword, glove, and helmet. And we want to add those 3 more items to our inventory of our main character. So let's say you walk and find a dead player items, sword, gloves, and helmet, and you want to wood them and add them to your original inventory. You can do this with append. Right now we have here 4 index, and we have here 3 more. So right now, if I compile and save, it just says 7. Yeah, 7 in total. So we've added the dead character items, the wood that we want to get, the sword, the gloves, and the helmet, to our original inventory, which hold a lot of potions. So this is how you can append another array to your original one. Thank you guys for watching. I'm waiting you in the next one. Alright guys, so we've covered everything about arrays, at least the basics, and now we're gonna start to talk about flow control, and in this video I'm gonna talk about branches. So let's right click here and type branch and see that the branch is under flow control panel, and when I click it you have 2 conditions, true or false, and an entry point and a condition which is a boolean. So let's try and set up a little branch. First, when the game starts, I want to go into this branch, and let's connect the string number 2, which is a boolean, get string, connect it over here, and we can control this branch with this string. So right now what it does is, if this string is false, it's gonna branch over here, and if this string is true, it's gonna go over here, the flow of the game. So let's connect this to this print string, and let's say player is alive, and let's create another print string, and let's call it player is dead. So let me give you an example. Let's say this branch is the status of our player, and this string represents let's say is player dead. All right, so this is a good example. Is player dead? Let me compile and save. Is player dead? If it's true, it goes here and it prints player is dead. If our player is not dead, it will go to false and it will say player is alive. So let me just check this, and let's click play, and it will say our player is dead. So right now the boolean player is dead, it's true. Let me make it false, and it will branch over here to the false condition, and it will says player is alive. All right, this doesn't limit the branch only to one. You can create branch and connect it to another branch. Let's say this branch, if it's true, and let's create one more condition. Let me get it. Is he stunned, for example. Let's player is this is in the true, so we're gonna go with the false, and the true will go here, that player is dead. If it's not dead, let's check if it's stunned, and if it's stunned, it will be player is alive but stunned, and I'm gonna Control C Control V. If it's not, player is alive and not stunned. All right, so the first condition is player dead, it is not dead, so we go to false. We get into the second branch. Is he stunned? Let's say is our player stunned, compile and save, and let's say our player is not stunned, it will go to false. and it will flow to this string, player is alive and not stunned. So let's hit play, player is alive and not stunned. All right. If I hit here true, and if I play it, player is alive but stunned. So this is pretty much what branches is all about, branching our logic to true and false and continue the flow of the game. So based on those branches, the flow of the game can flow either to the dead condition, which is this print string, or it can flow up to the second branch, it can flow up to the this print string where our player is stunned, or this one where our player is alive. So this is pretty much about branches, and I can't wait to see you in the next video. Hello again. So we're going to focus now on the next flow control that I want to show you. It is called sequence. So I'm going to right click here and type sequence, and it is under flow control sequence. And what this does, it's going to play whatever we connect here one after another. So let's connect event begin play and add 5 things. And let's say print string. And this will be 1, and I'm gonna place 10 seconds. All right, so this will be my first, my second, let me copy this, my third, my fourth, fifth and sixth, fifth and sixth. And guess what will this sequence does? It will play everything in order. So it will play first this one, then this will be my second, then this will be my third, my fourth, my fifth, and my sixth. And this will be the order that everything will be executed. So if you have some logic over here that you want to play first, and after this logic you want to play second, third, fourth, etc., but you want to play them with this sequence order from the first to the bottom, it will play this with this sequencer. So I'm gonna compile and save, and let me just play this, and you see the numbers 1, 2, 3, 4, 5, 6. It is playing everything in order from the first to the sixth. So this is pretty much about the sequencer, and what it does, it plays logic with the execution order from 0 to the last pin that you've added here. Thank you guys for watching this short one. I cannot wait to see you in my next one. Hello again, guys, and the next thing that we're going to be covering in this lesson is looping. So let's just get straight into it. I'm gonna right click here and type loop, and I'm gonna search for loop, this one in the switch flow control for loop. I'm gonna place it over here, and let me just first explain about this block over here. We have first index, last index, loop body, and completed. So what this will do, it's gonna loop and repeat the action here in the loop body until you meet these requirements about the first and the last index. So let me just show it how it works. I'm gonna connect here the event begin play. So when we start the game, we enter here in this loop body, and I'm gonna add print string like this. And I'm gonna put text looping, all right? And I'm gonna connect the loop body. And what this will do is it's gonna start the game, it's gonna go into this loop block, and it's gonna start printing this string. So if I compile and save, and let's hit play, it's gonna loop one time this one, because our first index is 0 and our last index is 0. So it's gonna repeat this loop one time. But if I put here 15, we're gonna have 16 looping texts, because it's gonna loop, it's gonna execute this print string 15 times. So the flow is for loop, go here, print the string, go back, the index is 1, again repeat, index is 2, repeat again, 3, 4, 5, 6, 7, 8, 9, 10, and until we reach the 15, it's gonna repeat the loop body. So let me save and let me play it. We have here 15 looping. Let me just tweak up a little bit the time, the duration. Let's try again. And here you see the looping that we have. And when this is done, you need to connect what we'll do when this block for looping is completed. So I'm just going to drag and drop here, print string, end of loop, just like that. Let me just put another color, let's say green, and let's put 10. And right now what we will see is it will loop and it will end loop. So the action is here. Event became play, start looping, loop this print string 15 times, just loop, loop, loop. And when you meet the last index, which is 15, it's gonna execute the complete action and the flow will go from here. So let me just connect one more. Let's say print string end of looping real end, so that you can see that we continue the action over here. Also, let's connect one more here, print string, and let's name it 1 because I want to show you how it's looping. Now what we will do, it's gonna loop those two blocks, the print string, so you can have a lot of logic over here, and it will loop this huge logic that you've connect over here until we meet the last index requirement. So I'm gonna start. You're gonna see we have loop 1, loop 1, loop 1, end of loop, and real end. So just final thoughts, how it works. Event begin play, start looping, comparing the indexes. Of course, you can always connect a string over here and give this string variable a different data over here, real-time dynamic in the game. So you can control this last index or the first index. So when it starts executing this block, it's gonna execute everything that you have here built up as a logic in this loop body. And when it meets the last index, it's gonna complete and it's gonna continue the logic over here that you have. So that is pretty much about the for loop block. It is very useful. We're gonna use it a lot in our projects. So thank you guys for watching and stay tuned for the next video. All right, so let's continue on with the next block, which will be while loop. So I'm just gonna add it over here, and let me add for loop 2 here. They're pretty much the same, but they have a little bit of difference over here. They have loop body, they have complete, and this one for loop has first index and last index, and while loop has a condition which is a boolean, which can take the true and false parameter. So that is the big difference between those two. So let me just delete this one. And of course, you need to connect the event begin play to your while loop. Here in the body section, I'm gonna place what I want to be looped. So let's loop a print string over here, and let's call it looping. And I'm gonna set up the duration to 10 seconds. All right, so this is my loop body. So I'm gonna loop looping over here. The text will be printed. And in my complete body, I'm gonna add another print string, which is going to say complete. All right. I'm gonna make it green color. And of course, I'm gonna place duration 10 seconds. Let me just put it like that and connect it over here. So what will happen right now is while loop will go, and if it's false, it will go straight to the complete section. But if it's true, it's gonna loop over here endlessly. Let's keep it false, compile, save, and I'm gonna show that it's gonna say complete. All right. So right now, when it's false, it goes straight to the complete option and it's not looping the body. But when it's true, this block is working. We say this block is true, compile, save, and right now we're gonna have an endless cycle because we don't have a condition that we say this condition will be false. So it will be an endless loop. It will loop the string endlessly because this condition doesn't have anything to change it into the negative, not true value. And once I played it, it's gonna stuck a little bit on Unreal Engine 5, and it's going to show me a message that this loop is infinite and you have to fix your blueprint. And how we're gonna fix it is I'm gonna put two parameters. Let's create loop 1, and let's create one more, loop 2. All right, they both will be integers, and I'm gonna get their values over here, just like that. And I'm gonna add not equal operator, so that one will be not equal to the other one. Let me just connect it like this. And let's say the first one I need to compile in order to have the value, and the second one will be 10. And what will happen is the first one will be 0, and it will be not equal, so it will set up my conditions to false. When those two are not equal, it will be true, and when those two are equal, it will be false. All right, I'm gonna save, I'm gonna compile, and let me play it, and we're gonna have the same error. Let me just go for here, and it is infinite loop again. And why is that? It is because this condition to be false, right now it's true, this one is not equal to this one, and those two conditions to be true, we need to make them true. And how we can do that is, I'm gonna drag and drop this one, I'm gonna click set, I'm gonna drag and drop over here, and I will search for increment integer, and I'm gonna connect this string over here, and I'm gonna set the incrementation with 1. So right now, what will this do? We're gonna start our game. It's gonna go into this block, and it's gonna say the condition this is not equal to this one, it's gonna be true, so we go to this loop. And what this does, it will add to our loop value just 1. And when this happens once, it will add 1, and this value will be 1. Then it's gonna say to the loop, we are still not false here, we are still true. So while we are still true, we're gonna print this again. We're gonna add one more number to this, and this will go into 2. And once we do this 10 times, it will go to 10. And this will return that loop 1 and loop 2 are equal, so this one will be false. All right, when we compile, we have an error which says the value generated from increment is not passed over here. And what I forgot is I need to connect my loop 1 over here, and I need to compile and save in order to say that this one will get plus plus. So right now, when I added this one, I'm just gonna get rid of this one, and this will add only one value to my already existing loop 1. I'm gonna set it up to 0. I'm gonna compile, save, I'm gonna run it, and now we are not having our infinity loop. So we're gonna loop here, looping, and we go to our complete. Let's summarize over here a little bit more. The game starts, we go into this block while loop. Those two are not equal, so we're gonna have this condition to yes. And when we have this condition to yes, we're gonna go and start looping our body into our print string. And this is an easy way to add 1 to our variable. If you want to add a different value, let me show you how you can do this. You can just drag and drop this, and we want to set this value to something else. I'm gonna drag and drop over here our value, and I'm gonna say add to our value from the operators, and I'm gonna connect this to this one. And right here in the add section, I can say whatever I want to add. Let's say this is 10, so let's add 2. Compile, save. I'm gonna play it, and we're gonna have only 5 of those looping text because we incremented with 2. So if you add 4 over here, this condition will never be met because we will never had 10 over here. So if you add 4, it's not going to work. If you add 5, it's gonna play just 2 texts. So keep that in mind, that you need to increment in order to match this second value, so this can be false, right? You can place another conditions over here, for example, less and equal, or equal, or greater than equal, etc. you can choose whatever logic you want over here in order to execute the complete action in our while loop. But the preferred method for me is to add increment integer over here. This is how you can increment your variable with one step on each loop. So this is pretty much how while loop works. It is similar to our for loop, but it has a condition over here that you can create different logic in order to execute true or false statement. This while loop must be taken care with cautious, because some of the times you can get into infinite looping, and this is not a good practice because your game will crash or your performance will be slightly lower. Thank you guys for watching this one, and I'm waiting you in the next one. Alright, so let's move on with the next block, which is do n. So I'm just gonna add it here in our event graph. I'm gonna right click over here and just type do n. And this one here in the utilities flow control will be the one that we're gonna use. And as you can see, it is pretty similar as for loop. Let me just get my for loop. It has enter, it has n, which is a number of times that this one should be called. Here we have indexes between which we want to call them. You have another reset function which can reset the do n. We have an exit and a counter. All right, so pretty similar, but they work differently. So let me show you first. I'm gonna connect my event begin play to do n, and in my exit I'm gonna place a print string. All right, so here I'm gonna connect my exit over here, and I'm gonna name this go go go. All right, right now from my n, I'm gonna tell Unreal how many times I want this do n to be called over here in the print string. So let's try with 4, compile, save, and let's play. And as you can see, we have only one time go go go. I'm just gonna increase the duration over here to 10. And why this is happening? Because this is not like for loop. Let me just get it again here, and it is shown by the icon. For loop is always executed and returned. For example, if I have 0, 5, and if I connect my print string over here, it's gonna print the string. Let me just connect it. It's gonna print the string, it's gonna go back, and it's going to repeat this action for the times that we've placed here from the first to the last index. The difference between this one and this one is because this one is executable only one time. As you can see, we have here a little arrow and n like a number over here, how many times we want to do this flow, and this arrow is showing one direction. So right now our event begin play will play, it will go into this block do n, and it's going to print string. And remember guys that I told you that event play is only called once, so this is why we have only one time printed go go go. So what we need to do is we're gonna need to call another event, which is event tick. And what event tick does, it's going to call this block every frame of our game. So for example, if our game runs on 30 FPS, this block will be called on each frame, so 30 times for 1 second. So our game runs on 30 frames per second. This block will be called 30 times for 1 second. If our game is on 60 FPS, this one will be refreshed each frame 60 times per second. And what I'm going to do is I'm going to connect event tick over here and disconnect this one. And right now what is going to happen, our game is running, for example, on 60 FPS, but in 4 frames I'm gonna call this do n because I've set up here 4, and it's going to print 4 times go go go, 4 times. If I set up here like 12, it's gonna do 12 frames. This is like update function. On each frame of the game we're calling this. And let me just connect an input over here. So I'm gonna F keyboard, I'm gonna type F keyboard, and I'm gonna connect it over here. And let's say 3. So what I'm doing over here is with a pressing of a button, I can reset this. And let's say every time I click F on my keyboard, I'm gonna print another 3 strings over here for each 60 frames of my game, for each event tick. And what I need to do in order to enable my keyboard to work, I need to put enable input, this block, which will make my keyboard functional. And I'm gonna connect player controller over here. All right, this is in order my F key to work. I'm gonna compile and save. And right now, just watch. First is go, go, go. And when I press F on my keyboard, I'm adding more go, go, go to my game. All right. So this is pretty much about do n. Do n will execute number of times, and you need to connect it to event tick. If you want this to execute the right way, you need to connect your logic in the exit, and you can reset it here with another logic. Maybe player died, or maybe you're resurrected and you need to reset this logic again, etc. And this little block is added in order my keyboard to work with this F button. So thank you guys for watching this one. I'm waiting you in the next one. All right, welcome. The previous one was with do n, and right now I'm going to show you do once, which is another do method. So I'm going to type do once in this flow control, and it does what it says. It is going through that block only once. So if I connect my event tick to this one, it's going to be called only once in those 60 frames that we have set up for our game. And if I connect it over here, I'm gonna compile and save, and it's gonna print my string only once. All right. And if I connect here my F from the previous lesson, and I'm gonna leave this enable input and get players controller in order my keyboard to work, I'm gonna compile and save. It's going to play this go, go once, and if I hit my keyboard, I'm just gonna spam with one message over here. But if I want this one not to be executed when event tick starts, I'm gonna check this boolean over here to be true, which will say this block not to be executed from the event tick, but rather when I reset it here from the keyboard or any logic that I have over here. So I'm gonna compile, save, I'm gonna play. And right now we don't have go, go, go as a starting point. And if I press my keyboard, I'm getting the go, go text over here. So this one defines if this do once needs to be called when this event tick starts. But this is not something very useful to do, because what we can do over here is pretty simple. I can just, let's say, disconnect over here, and I can just connect this print string over here, compile, save, and I can play, and I can start clicking F on my keyboard, and I just can execute this command from here. So this is not something very, very useful. You can use this do once if you need it, you know that it's there, but this is a more simple and clear way to do it if you want to create some kind of an action like this, because this is not something so useful. But you can find any application for this in the event tick or maybe event begin play if you want something to be called just once. Of course, you can do it with do any and just set the n time of plays, how many times you want do any to be played, and you can set it to be only one, which will work just like this block. But this one is more simple, and maybe you can find any application for it in your game. Thank you guys for watching. I see you in the next one. Hello and welcome back again, guys. In this short video, I'm going to be talking about flip-flop, which is toggling between two parameters. So I'm just going to right click and use flip-flop like a name. And what this does, it's pretty self-explanatory, A or B, and it's gonna flip and flop between A and B. Here you have a variable which is saying is A true or false, which will lead to one of the choices if you don't want to flip and flop. For example, let me just print string. Let's just type attack 1, and this will be my attack number 2. And I'm gonna change this one to green. to a little bit greenish over here. And what we will see, it will flip and flop between attack 1 and attack 2. And if I play over here, attack 1, attack 2. And you see this on each frame in my game. My game is running on 60 FPS right now, so we have this pretty often. And if I connect this to event begin play, it's just gonna execute the A1 because we call this only once, and the flow goes over here and then come back on the next frame in order to check and execute the B option. And let me just show you, if you do this, it will just say attack 1 because we don't update this on each frame. So I'm just gonna leave it here in the event tick and show you once again what it's doing. It is switching between those two, and let's say this is defense. Let's compile and save so it's a little bit more clear. You can see attack defense on each frame that we have. This is pretty handy flip-flop. We use it oftenly in our games. You can use it in order to set up logic, for example, on flip attack, on B defense. Maybe you have an idle clicker that is attacking and defending. Or there is another case, for example, opening doors. You can A, open the door, and B, close the door, etc. So flip-flop, pretty handy, flipping between A and B. And here you have a boolean which will represent which one is the current state. If you don't represent anything here, it will flip between A and B. Thank you guys for watching this one, and I'm waiting you in the next one. Hello again to everyone. In this one, we are going to talk about the gate, which is pretty good and pretty handy. I often use the gate. I'm just gonna right click here and choose gate under the flow control, this one, the gate. And it has 4 options here: enter, open, close, toggle, and here the exit, what it needs to be executed, and start closed. Let me just delete this one, and let's type it gate is open. Gate to hell is open. All right. So I'm just gonna connect here from exit to exit, and I'm gonna connect my event tick to my enter. All right. I'm gonna compile and I'm gonna save, and I'm gonna play. And as you can see here, nothing is happening. Why is this? Because I've set up my boolean about start close to be true. That if you have this boolean start close to true, this one will be closed. Think about the gate like a real gate. You have an open clause, close one, and toggle. Toggle will mean open and close the gate. And start closed will mean the gate is closed, so no warriors or anything can enter. When you open the gate, the flow will start, and you're gonna see the gate to hell is opened. So when you close it, the gate to hell will be closed. And when you start toggling, it will open, close, open, close. So let's set up this one to be played with hotkeys. Here I have my enable input and get player controller set up so that my keyboard will work. So I'm gonna type a keyboard, and I'm gonna search, for example, let's say B, and let's say C keyboard. I'm gonna use C, and let's use T keyboard. Let's find the T. So I'm gonna connect my B to open. I'm gonna connect my C to close, and I'm gonna connect my T to toggle. And right now, if I press B, I'm gonna open the gate, and it's gonna start printing gate to hell is opened. If I press C, it's gonna close the gate, this one, and this printing will stop. And if I start pushing T on my keyboard, it's gonna open and close my gate. So it's gonna toggle between open and close. All right, so let's hit play. Nothing is happening. I click B, so I open the gate. I click now C and close the gate. B, opening, C, closing the gate. This is just working like a real gate. I'm opening and the flow control goes and execute the print string. With C, I'm closing it. And if I start pressing T, it's going to open and close. This is by pressing T on my keyboard, opening and close. Let me just set up the time here for printing 0.2. And let's hit play. In order for you to visualize it better, I'm just pressing T, opening and closing. All right. I'm gonna press B, open, press C, close, B, C, B, C. So this is pretty much about the gate. It works just like the name. It's a gate. It has open, close, and toggle connection. You can connect logic here in order to open, close, and toggle it. And in the exit, you here place everything you need like a logic to be executed. You connect it to Eventic in order to execute this in real time. If you want to execute this only once when the game starts, you can connect event begin play. So this is pretty much about the gate. Thank you guys for watching, and I'm waiting you in the next one. Alright, welcome back. In the previous video we talked about the gate. Now we're gonna move forward and we're gonna talk about multi-gate. So I'm just gonna right click over here and type multi-gate. Here under the flow control you have multi-gate. I just double click, and multi-gate is in some way similar to the gate, but it has some more parameters. So let's talk about each one of them. I've just left my enable input and my get player controller connected to event begin play in order to get the input from the keyboard. So here I've dropped the G key. So you just need to right click here and type G keyboard over here in order to drop this G key. And I'm gonna connect here at the multi-gate. So when I press G on my keyboard, I'm gonna call the multi-gate. All right. Here we have out 0, out 1. We can add a lot of outputs, and those outputs are different logics that our multi-gate can execute. So let me just remove a few of them. I'm just right clicking and removing, and I will leave only 3. The first one, I'm gonna connect to the print string over here, and I'm gonna duplicate my print string with Control D on my keyboard. I'm gonna place here 2, I'm gonna connect it, Control D, and I'm gonna connect one more. So right now I have 3 different executables here at the output of our multi-gate. And let me just change the colors so they can be more visible, and put 1 second per each, just like that. All right, so I have 1, 2, 3 here at our outputs. So what will happen now is when we press G, we're gonna go into our multi-gate and we're gonna go and execute out number 0, and it will print 1. Then the next time that we press G, we're gonna execute again the multi-gate, and we're gonna execute the next one, out 1, out 2. Let me just demonstrate this. I'm gonna play here, and I'm gonna press G on my keyboard. You can see 1, G, 2, G, 3, and when I continue hitting G on my keyboard, nothing will happen. And this is because this is executable order from 0 to 2, and when you reach 2, it's not gonna go back to 0. You don't have this loop over here. So when you execute 3 outputs over here, the multi-gate will stop working. In order to execute them again, like a loop, you just need to enable this boolean, and right now with this boolean enabled loop, it will loop the outputs over here. So when I press G, I'm gonna go to 0, 1, 2, and when I press again G, it will come back to 0 and it will repeat itself in a loop. Let me just demonstrate this pretty quickly. I'm pressing G, 1, G, 2, G, 3, G, 1, 2, 3. And you can see that it repeated itself because we've enabled our loop function over here. If I click here on is random and I enable it, it will randomly pick one from the 3 outputs over here when I press G. Let me just press G, 3, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. And it is executing on random one of the numbers in the output section. All right. So loop will loop your whole output. Random will pick one of these. Of course, reset will do the same. For example, if we let me just add one more key, T keyboard. So let's just add Z and connect it to the reset. And what reset will do, it is just like the gate. So if I turn off the loop and the random and I play my game, and I press G, 1, 2, 3, and continue pressing G, nothing will happen because our loop boolean is not true. But if I click Z, it will reset my multi-gate. And again, if I click G, it will start from the beginning. Z, G. So that's the point of reset. It's just like the gate. It resets the multi-gate and it starts executing 0, 1, and 2 again. This is because we turn off the loop, and if we want manually to reset the multi-gate, we can do this with a keyboard. In my case, it's Z. And the final thing that I want to show you is the start index. Start index right now is -1, which means this start index variable is not working. This is to turn it off. But if I want my start index to start from 1, let me just type 1. Right now, when I press G on my keyboard, my multi-gate will start from 1. Let me just demonstrate this pretty quickly. I press G on my keyboard, so we start from 2, G, 3, G, 1, and everything is over. So the logic here is start from 1, loop to 2, loop to 0, and end it. This is because we already execute 1, execute 2, execute 0. You need to execute everything in your multi-gate. Let me just show you. If you start from 2, it will execute 2, and it will come back to 0 and 1. Let me just demonstrate this pretty quickly. Again, with G, we're going to start with 3. I'm going to hit G again, continue with 1, continue with 2. Clicking G won't do anything. If I click Z to reset and start clicking G, 1, 2, you're going to see that they repeat itself. And if you want to turn it off, -1 will do the trick. So this is pretty much about the multi-gate. It's pretty handy. You can execute different logic by using the multi-gate for different stuff. This is pretty useful flow control block. So thank you guys for watching this one. I'm waiting you in the next one. Alright, welcome to the next lecture. In this lecture, we're starting a new chapter where we're going to talk about events, functions, and macros. I'm going to explain very briefly what events, functions, and macros are. We're going to be starting with an event. Event is when something happens in your game. For example, when your character starts to block an attack, when you pick up, for example, a health pack or something like this. Events can be triggered, and you can trigger a lot of events at the same time. So multiple events can be called at the same time, and different things can happen at the same time. So this is very important to know that you can overlap events and call as many as you want at this particular time. Keep in mind that events accept time action, like node delay and node timeline. I'm going to give you a little example. For example, if your character is using a shield to block an attack, you can add a delay, the node delay, in order the shield to come forward with the animation. For example, you can have 0.03 seconds in order to shield to go forward and then execute the defense event. And while your player is going with the shield forward, he can take damage from the attack if the player don't have in mind that there is a little delay between blocking and shield going forward. So this is something that you can use in your events. You can use delays, you can use also timelines. The next thing is that events don't return value. So when you execute this event, it cannot return a value to you. Values are returned only from the functions and the macros. The other thing is that the events appear in the event graph. Unreal does not have a separate graph for events. All right. Moving further is the functions. So the functions are similar to events, but they have some differences. So functions are action that is performed and this action is performed instantly. So they're like actions that triggers and bring the result instant. Keep that in mind that also functions, they don't accept time actions. So you cannot put a delay in a function. Functions are executed and the result is given instantly. This is something that you need to keep in mind. And also the functions can accept input and output. What this means, compared to the events. They can accept values and they can output values, so they can return results to you, which result you can manipulate and continue with your game logic. They don't accept custom events, and this is simply because they don't accept time actions, and custom events can accept time actions. This is the logic behind the acceptance of the custom event. They don't accept custom event because they don't accept time actions. And finally, functions has their own execution graph, and they're not represented in the event graph that we've worked so far. We're going to be covering this later on. The next thing that we're going to talk about is macros. So macros is a collection of different actions. So let me just make you a little picture here. For example, if this is an action 1, this is an action 2, this is an action 3. All right, you can combine them, all the actions over here, and create a macro. All right, and you can use this macro, this one, you can use it and call it wherever you like in your code multiple times. You don't need always to have these 3 actions separately. You can have them under a macro, and you can call the macro multiple times in your code. Keep in mind they don't accept time action either, so they don't accept custom events too, which means that they are executed instantly, the macros. And just like the functions, they accept input and output, so they can output results that you can then use and manipulate. The next important thing is that they are not seen in C++, and why they are not seen in C++. So for example, when you compile your game, macro has visual effects only to organize and reusability in Unreal Engine 5, but when you compile your game, macro is not read and it's not represented in the code. Only the actions over here are represented in C++. Keep that in mind that they are not seen in C++, and they're mostly for organization, reusable, and visual fidelity of your code. And finally, they have their own execution graph. Moving on to the compare table, where we can summarize event, functions, and macros. So the first row is actions. Events can accept time nodes, so they can be manipulated in time. You can delay, you can execute events based on your game timeline. Functions and macros don't accept time nodes, so they're executed instantly. About the values, events can only accept input values, so you can only give values to your events, and functions can accept input and output, as also macros does. Macros accept input and output. About the graphs, event graph is the one that we've worked previously, so events are happening there. As you've already know, we had events on begin play, event tick, etc. Those are the events. And functions and macros has their own graph. About C++ visibility, events can be seen in C++ code like functions. Only the macros cannot be seen in C++ because they're for visual fidelity, organization, and reusability in the blueprint system of Unreal Engine 5. Thank you guys for watching this video. In the next video, we're gonna explain everything with use cases. Hello everyone, and welcome back with the next video. Before we start talking about events, functions, and macros, I want to show you another way how you can organize your event graph. So let's just start. I'm gonna drag and drop 3 integers over here, and I'm gonna use the get function of them, just like that. And let's say I want to do a mathematical operation divide, just like that. And I'm gonna add those 3 to be divided. All right. So this is a block that I have of logic, and it took some space over here in my event graph. And if I have multiple blocks, for example, something like this, it's gonna take a lot of space and it's gonna get a little dense and confusing. What you can do to organize everything, you can collapse this block. For example, I'm gonna select everything over here. I'm gonna right click and click collapse nodes, and here it's gonna create a new block which gonna contain the mathematical operations that we want in this case, and I'm gonna name it here divide math. All right, And when you hover on it, you can see the actual logic behind this collapsed graph. And if I double click on it, I'm gonna enter inside, and I can add more logic to it. For example, like that, compile, save. And here from the menu, from the hierarchy, I can go to my event graph. And this looks way better if you have multiple blocks. Here, bear something in mind that if you copy this one, this will be whole separate block. So for example, if I go in and add one more over here, variable, and compile, save, and go back, this one will have 5 variables, and this one will have 4 because they are separate entities and they work separately. They are not mirrored. Here in the event graph, you can see your collapse graphs, and just double click if you want to go straight to them. This is an easy way not to get lost in the event graph to scroll. So I can just double click here and go into my divide math and just make some changes. The other cool thing is, as you can see here in this block, I cannot connect anything outside and inside. What you can do here is from the details panel, you have inputs and outputs. So if you want to make the final calculations, you need in the outputs to click plus and to add final calculations, and it needs to be from integer. And here from this block, I can get my functions over here connected to the output. I can connect my output for the final calculations to a print string. Let's put a print string over here. Let's connect here to here. It will automatically convert my integer to a string. I'm gonna place here 2, and I'm gonna print this on event play. And let's set up the integers. So 1 divided by 1 divided by 1. It's gonna tell us it will be 1. Let's try 1. All right. So this is how you can collapse some of your block logic and get output out of it. And if you want to input something over here, for example, I want to input a variable that is outside, like this. I want to input loop 1 here and my divide math into some block. I can do this by adding an input to the block. I'm gonna compile, I'm gonna go back, I'm gonna select here, I'm gonna select inputs, let's say loop 1 input. I'm gonna select integer, and I'm just gonna connect this one, the loop over here to the loop over here, and I'm gonna connect the first input to my first row of the block. So here you can add different inputs, as you can see, as many as you want and as different as you want. And this is a good way to organize everything in your Unreal Engine project. And it's gonna look better if you organize everything in your event graph like this, because you're not getting lost into your logic, and this event graph is not getting ridiculously complex. This is how you can optimize it and divide everything by using the collapse function in Unreal Engine event graph. Thank you guys for watching. I'm waiting you in the next one. Alright guys, welcome back. So in this short video, we're gonna summarize what event is, and I'm gonna explain it again, because in the previous video we just mentioned it, but we didn't deep dive into it. So let's just get started. Here we have event begin play, and events can be recognized by the red label that the blocks have and this arrow over here. And they always start with event. Those are the events that are default for Unreal Engine. So the first one is event begin play. This event will be executed when you press the start button of Unreal Engine or when your game starts. The second one is event actor begin overlap. What this does is when one actor overlaps with another actor, it is triggered and the logic over here, it is executed. And the final one, the event tick, as I've already mentioned you in our previous videos, event tick is happening on each frame that our game renders. So if our game is on 60 FPS, it will execute this event tick 60 times for 1 second, so 60 frames. Let me show you another event. It is keyboard. So keyboard events, as you can see here, let's try with A. When I drop it over here, you see that it is red, which means this is event. And when I press the button A on my keyboard, it's gonna execute the logic over here. You can do the same for the release. So if I press A and then release it, it's gonna execute this logic over here when it is released. You can also get events like touch events for touch screen, different stuff. You can also get Steam events, Steam Touch, of course. You can also get mouse events, left mouse button, right mouse button. All of those are in red, which indicates that this is an event. And previously, like I told you, events are called in time. This event begin play is called when the game starts. This is called when you press something on your keyboard, in my case A. This is called when you middle mouse button you can press or release, etc. So in general, Unreal has a lot of events that you can call and you can structure here in your event graph. And this is the main idea behind the events. In the next video, I'm going to show you how we can create our own custom events. Thank you guys for watching, and I'm waiting you in the next one. Hello and welcome back. And now we're gonna go and create our first custom event. So I'm gonna right click here in the event graph and type custom event. And under add event, you're gonna see add custom event, 3 dots. I'm gonna click on it and I'm gonna rename it and call it, let's say, upgrade my sword. All right. So this will be my custom event that will upgrade my sword, and I'm gonna make a print string, and I'm gonna just execute a text which will call sword is upgraded. All right, and I'm gonna place the duration like 5 seconds. Okay, and let's see with a green text. So now I have my upgrade my sword custom event, and I can place it somewhere over here. And this, for example, is my complete logic for the sword. Or maybe let's add a delay between sword upgrading. Let's create, I'm gonna use delay. So here in the flow control, you can select delay, and this will delay my sword is upgraded. So let me create one more print string, and I'm gonna name it upgrading, and I'm gonna connect my upgrade sword here. I'm gonna connect my upgrading over here and connect it to this one. So what will be the flow? I'm gonna call my upgrade my sword event. It's gonna print this string upgrading. It's gonna wait 3 seconds, and then it's gonna type sword is upgraded. So this will be my workflow. But how can you call this function? This is a function. So I'm just gonna select everything and click C on my keyboard, and let's call this block sword upgrade logic. All right. So this block will keep my sword upgrade logic, and this will be the event that I need to call. And how we can call this event? Let's say we click F on my keyboard, F keyboard. This is an event, and here I'm gonna search for the event. I'm gonna right click here, and I'm gonna search for call, and here in the call function I'm gonna select upgrade my sword, and this is a function to call my event. Right, one more time, right click. You can find it by name, upgrade my sword, and you can find the call function over here with the name that you put in your event. So right now I'm gonna connect my press to my upgrade my sword function, and what will happen, I've already here connected on event begin play the input of the keyboard, and what will happen right now is when I press F key, it's gonna call my function over here, the upgrade my sword, and it's gonna start doing this logic over here. All right, and every time I press F on my keyboard, it's gonna do that. Let's compile and save, and let's demonstrate. Nothing is happening. I click F on my keyboard, upgrading. We're gonna wait. Sword is upgraded. All right. Let me just wait until this text disappears. I'm gonna click F again on my keyboard, upgrading. We're gonna wait those seconds. Sword is upgraded. So this is pretty much how you can call your events, and this event can be placed anywhere in your blueprint. It doesn't matter. And if you want to go quickly there, you can just double click over here and it will redirect you to the event. All right. So this is pretty handy, and we're going to use a lot of custom events for our logic that you can call. Keep in mind that I'm going to show you how you can call custom events from other blueprint classes, that you can have this connection between different blueprints. Of course, you can call this event on begin play, just like that. Let me just show you. Let's play. It's gonna be called on begin play. You can call it when an actor overlaps another one. So this is pretty much about custom events. This is pretty handy. And of course, after you call this custom event, you can continue your logic over here. It doesn't need to stop. And your custom event, you can build up your logic, whatever you like, you can add over here. And when you call it, it will be executed. So thank you guys for watching this one. And I'm waiting you in the next one when we're gonna cover more topics about events. All right. So we now know how to create custom events. Let me show you how you can add inputs to your custom events. And by that, I mean here in the event tick, you have a delta seconds, which you can plug in here and define the delta seconds over here. Here you have other actors, etc. Let me just tweak a little bit more the logic over here. I'm going to create new print string, and I'm going to connect it over here to this one. And I'm going to put again 5 seconds, and let's make it pink. Okay, so the first thing that you need to do is you need to click on your upgrade my sword event, and here in the inputs I'm going to add 2 variables. The first one we're going to call it sword type, and the second one I'm going to call it sword rarity, just like that. And here in my upgrade my sword, let me just get it again, call, and go to call function upgrade my sword. You can see 2 new parameters. I'm gonna connect my, let's create a key from the keyboard, F keyboard, and let's connect it when we press F on our keyboard. Let me just move those a little bit up. When you press F on my keyboard, I'm gonna call my upgrade sword function, and it's gonna start upgrading. It will have a little delay of 3 seconds, and it's gonna print those strings. And what I want to do is I'm gonna connect my sword type over here and my sword rarity over there. And let me just clean this up because it overlaps. Let me just double click over here and connect it like that to look more beautiful, everything to be arranged. This is pretty important when you're working with blueprints, everything to look clean and nice. All right, so this is my connection. And right now here in my upgrade sword, let me just type in the sword type heavy sword, and in the rarity, let's say epic rarity. All right, and I'm just gonna change the color to yellow to look epic, and my sword type will be heavy. So now the logic is like that. We're gonna press F key, we're gonna call upgrade my sword function over here, and those 2 variables will be assigned over here to the sword type and sword rarity, and they're gonna go into the print string and into the second print string, and they're gonna render this string over here. Let me just show you how it works. Let's play it. Let's click F on my keyboard, upgrading, epic rarity, heavy sword. All right, we're gonna wait until this disappears. Click F on my keyboard, upgrading, epic rarity, heavy sword. So this is how you can create new inputs over here and assign it to your logic in your event when you call it. Of course, we can drop here a print string that is outside, and you can tweak it up in the editor, or you can tweak it up with the code and connect it over here, not to be hard coded in this upgrade my sword function. And you can connect a second one in order to execute this logic. So this is pretty much how you can add different inputs to your custom events. And of course, you can add as many as you want and as different as you want. Let's say integer. Let's say we want array over here, and you can connect it. This is pretty much about the inputs in custom events. Thank you guys for watching, and in the next one, we're going to start talking about functions. Hello again. In the previous video, we've talked about events, custom events, where you can create your inputs. And now it's time to start with the functions. I'm just gonna move this one, this upgrade my sort event over here. And I'm gonna leave this one over there. Let's create a custom function. There are two ways to create custom function. The first one is go here, and from the plus, you click plus. And as you can see, it creates a new graph just for that function, and let's say multiply damage of sword. This will be my function, multiply damage of sword. And first, from the previous lessons, I told you that functions has their own graph, and you cannot delete the first block of the function, which is the block that executes the function. Keep in mind that functions has no delays and no custom events. I can only call the events, but I cannot create events. So for example, if I want to call my upgrade my sword event, I can call it over here, but I cannot create a different event. All right, let me create simple logic over here. Let's create a print string, and let's connect this, and let's say +1 to damage. All right, and this will be my function that will multiply, let's say, x2 to damage. This is just a visual representation. I'm gonna compile and save, and here I'm gonna click in my event graph. Now if I go here and drag and drop my function, here you can see that we have the same thing as this one. This is how you can call your previous event, and this is the custom function that we've created. All right, I'm just gonna detach this over here, and I'm just gonna connect f to my function over here. I'm just gonna go now, compile and save, and now when I play my game and click F on my keyboard, I got x2 to damage. All right, pretty cool. We've created our first custom function. But the best thing about functions is that you can call it over here, which is pretty cool. Or we can do this, we can connect to our event, and we can do and call our function over here after this print string. So let's multiply our damage, drag and drop over here, and let's place another print string like that, and like this. We are upgrading our sword, so let's say here our damage will be multiplied, and let's say multiplying damage. All right, and I'm gonna place 4 seconds. Let's make it bluish. Let's put 2 seconds, and let's make it a little bluish. All right, and now what is going to happen, it is going to execute this one when I press my F key, and it's gonna multiply the damage print string, and it will show the damage that is multiplied. Let's try. Click F on my keyboard, upgrading. Now we have heavy sword epic rarity. Now what we need to do is we need to add a little delay over here between those two. I'm gonna connect here and here, and I'm just gonna delay with 5 seconds. Because this block is 5 seconds, I'm gonna delay it, and then I'm gonna render the next one, the print string, and this one. All right, compile, save, hit play, hit F on my keyboard, upgrading. All right, I got my heavy sword, epic rarity. We wait 5 seconds, and then we get multiplying damage, x2 to damage. Of course, we can delay this too. I'm gonna Control C, Control V. Let's delay this too. If you want a good workflow, I'm gonna delay this with 3 seconds, compile, save, and now everything will go in order. Click F, upgrading my weapon. We have heavy sword with epic rarity, and then we have multiplying damage, and let's see, x2 to damage. Great. This is another way how it works, how you can call your custom functions that we've created. And if I double click on my custom function, it will redirect me over here where I can create more logic. Another great thing is that this custom function is reusable. So what I mean is, if I let me control and paste it over here, we have second one. And when I go here, and let's add another print string, and let's say plus 4 to mana, for example, with 4 seconds. Compile and save. And now this multiply damage of sword will be the same as this one. So if we want to execute the same code, the same function in different blocks, in different logic of our game, I double click here, I have these print strings. I go here, double click here, I have these print strings. So this is pretty useful, and you can use your custom functions wherever you like in your event graph. Let me show you finally another method how you can create functions. Let's say we have print string. We have 2 print strings connected. What you can do is select those 2 print strings, right click, collapsed function, which will create a new function, print function, let's say. And if I double click on it, you can see that we've created this print function with just those 2 print strings. So this is another way how you can create functions. And there is one more thing that I want to show you. If you right click over here and click expand node, you're going to bring back the nodes over here that you've created. And the final thing that I want to show you, of course, you can add inputs and outputs to your functions too. You can add over here with the plus buttons. You can add different parameters to your input and output. And when you double click on your function, you will have print function, which will be the start of your function, the inputs, and return node, which will be the end of your function, where you can return some values to your event graph in order your logic to continue. This is pretty much about the functions. Thank you guys for watching. I see you in the next one, where I'm gonna show you in details the input and output. Hello again. So let's continue on from the previous one about functions and their inputs. As I showed you at the end of the previous video, you can add inputs and outputs to your functions over here, from here. Let me just add 2 parameters and let me make them integers. And I'm gonna call this, let me check my variables, loop1, and the second one will be loop2, all right? And this will be result. All right, so let me just go into this one and let me show you what it will do. Let's connect our print string over here. Here you can make some logic, and here you're gonna give a result. Let me just delete those 2. Let me just make a simple multiply. So I'm gonna multiply those 2 values, and I'm gonna give the result over here. All right, and I'm just gonna connect my multiply damage of sword to my return node, so the flow can go from here to here. All right, so I'm gonna compile and save. I'm gonna go to my event graph, and I'm gonna connect my 2 loops over here, loop 1, loop 2. I'm gonna give them, let's say, 2 and 5. So the result over here should be 10. I'm gonna go here and make a print string where I will display my result over here. All right, pretty good. So now when I'm just gonna disconnect over here in order to show you the function, how it will work. Now when I press F key on my keyboard, I'm gonna call this multiply damage of sword function. It will execute this mathematic operation, and it's gonna give me a result over here. And the result will be printed over there. Let's go, print, let's start the game, click F, I'm gonna get 10. That's it, pretty simple. And the power of Unreal Functions is that this function can be modified a lot more. Let's say we can multiply the result with the second one and get the result. So right now what will happen is we're gonna have here 10, and we're gonna multiply it by 5, so we're gonna have 50. Let me play F. We have 50. Great. And of course we can go here and maybe we can do add, and here we can add this one to this one, and we can render the result here in the return node. So right now we're gonna have here 50, and to those 50 we're gonna add 10 more, and it's gonna be 60, just like that, 60. So the functions are pretty important, and I strongly advise you to get comfortable with them. You can do a lot of operations here in a function, and then you can reuse it over here many times. Let me just copy and paste this function over here, and let me just connect this print string here. Let's say this loop is 10, and let's connect another print string, just like that. Let's say 5, and this mathematical operation will be executed again, and it will take in action that here we've put 10 and 10, and it will give us a different result by the same function. Click F, we have 60 and 1100. This is pretty handy to use those functions and to have different inputs and outputs of your functions. And you can use those functions to create pretty flexible and reusable code. So I strongly advise learning the functions. We're going to use them a lot in order to construct our code to be very clear, very optimized, and very useful. Thank you guys for watching this one. I'm waiting you in the next video when we're going to start talking about macros. Welcome back to everyone. Now we're going to start talking about macros. Macros are mostly like functions, but they allow better customization. So let's create our first macro. From here, from the macros tab, I'm going to click plus, and I'm going to name it macro1. All right, so this is our macro. They have their own graph over here where you need to make the logic only for this macro. Here is my main graph, and here is my construction script. So let's go back to the macro. And here in the macro, we have input and output. Just like the functions, in input, you get some values, you do some logic over here, and in output, you get them out of your macro. So let me create 3 quick integer values. So I'm going to select integer, and I'm going to name it int1. Let's go to the second one, int2, to the third one, int3. All right. And then I'm going to add them together. I'm going to go into operators, add. So I'm going to add the 3 values together. I'm going to add one more pin for the third one. And then I'm going to connect my add block to my output. There are 2 ways to do this. So the first one is to click on outputs over here and click on plus. And you're going to create a new parameter where I'm going to call it output, for example. Or you can just drag and drop over the output and it's going to create it automatically. So this will be output. All right, I'm going to compile, save. I'm going to go back to my event graph where my main logic and events happens. So now I'm going to go into my macros. I'm going to drag and drop, and I'm going to have our 3 values over here and output. All right, let me show you if you create a new macro, and if this macro is drag and dropped over here, it is empty. It doesn't have anything inside like input, outputs, any logic. And this macro will look like this. If it's empty, you cannot connect anything to it because you need to create some logic inside of it. All right. So right now my macro is adding everything together. So I just put 10, 5, 5. All right. And I'm going to make a print string, and I'm going to connect my output to the string. So I can get this value in our console in Unreal Engine. I'm going to put 10 as a duration, and on event begin play, I'm going to make this print string work. Now I'm going to go back here and let's see the result, 20. All right, we have 1 times 10 and 2 times 5. All right, I'm going to go back here. So this is how the macro works. And if I double click on it, I'm going to go inside this logic. I often use macros for mathematical tasks, like you can convert centimeters to meters. you can convert kilometers per hour to kilometers per second or something like this. You can create different macros in order to have a huge library of different mathematical functions that you can use in your game. And another thing that you can do with macros is if I Control-C, Control-V this macro, so it's gonna perform the same mathematical operation, but I can change a few values over here and have different results. Of course, I can copy and paste it again. So I can have the same function, but I can change only the values over here, or I can, for example, assign new values over here and just use this variable in order to work with this macro. But in the core, the mathematical operation in the macro are the same. You can reuse this macro all over your Blueprint event graph. All right, guys, thank you for watching this one. Alright, welcome back with this next video. In this video, I'm going to talk about macros, how you can make them executable. Alright, so let's just start. I'm going to double click on my macro. And as you can see here in the event graph, here from the event play, I have an execution over here, but in my macro, I don't have any way to plug in my execution. So I can go here, I'm going to select the inputs tab, and here I can add one and name it in. Go here and select exec, and this will be executionable. And now I'm gonna just drag and drop it because I want it to be at the top. And on my output, I'm gonna click plus and call it out. It's gonna be executionable. I'm gonna make it to the top over here. And right now what I can do is I can add here multi-gate, multi-gate, and I'm gonna connect my in. And I'm going to connect my out 0 to this one, and I can add more outs. So let's say this is out number 2. I'm going to place it above. I'm going to connect out number 2. All right. So here I can, with my multi-gate, I can say, let's say a random number will go over here with the out. And let me just create a little logic over here. As you can see here, we have our executable. So I'm going to connect this over here. And in my out 1, I'm going to print string. In my out 2, I'm going to print string again. So in my out 1, I'm going to have this, this value, this added value over here printed. And here I will not have them. So let's say this is fail. And let's keep this one like that. I'm going to compile, save. I'm going to hit play. I'm going to have fail, because right now my random multi-gate is going into the output 2. All right, let's try it a few times to see if we can get the success. Here is fail, 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 success, 20. All right, so it's working great. Right now I have a random number over here and a random event. All right, of course you can add, for example, branch, and you can control this through a condition. For example, this will be true, this will be false, in will be over here. And right now what it's going to do is, if this condition is true, it's going to go here. If this condition is false, it's going to go here. All right. So this is pretty much how you can create executionable from the macro, which is pretty handy. You can add as many as you want outs over here. If you make some big logic over there, you can add, for example, let's add a few more, and you can have a lot of outs over here connecting your event graph with more and more logic. And of course, if I Control-C, Control-V this macro, it's going to be the same. You can use the same macro. You can just give it different parameters over here. And of course, you can add more ins over here if you want to connect more input into this macro. Thank you guys for watching this one. In the next one, we're going to talk about macros library and how you can create one. All right, hello again. And in this video, we're going to talk about macros library and how you can create one. So here in my content browser, under my folders, I've created a new folder called macros library. I'm going to right click over here, and I'm going to go under blueprints, and I'm going to select blueprint macro library. And from the pick parent class, I'm going to select an actor. I'm going to name this as mat macro library, So I'm gonna do here in this library mathematical operations. I'm gonna double click, and here in my blueprint I have list of different macros that I can create. I can add more macros over here, or I can just select them and delete them. So the first one will be transforming meters to centimeters, just like that, meters to centimeters. So in my input here, just like the macro into the event graph, it is just the same. This is the same graph, but in library. I'm gonna click here on the inputs, and I'm gonna say this is meters. I'm gonna select integer, and here I'm gonna say this is centimeters. I'm gonna leave it as integer. All right. And now here in the input, I'm gonna drag and drop and put multiply. So in order to have centimeters to meters, I need to multiply by 100. I'm gonna connect it over here. I'm gonna save it. So right now I have meters to centimeters. All right. And I want the vice versa. So I'm gonna create a new macro, call it centimeters to meters. And I'm gonna make the same thing here. I'm gonna make it centimeters. Here, in the output, I'm gonna name it meters. And this time I'm gonna divide, and I'm gonna select centimeters over here, connect it to meters, and divide by 100. All right, I'm gonna save this. And right now I have two macros that I can use in my blueprints if I need this conversion from meters to centimeters or vice versa. All right. And now I will go into my blueprint class. And if I right click over here and start searching for this macro, we already have it here in this library, but we need to find it, centimeters to meters. All right. We have this macro. The next is meters to centimeters. All right, we have this macro. And what I need to do is I need to assign two values over here, here and here. And let's create this. Let's set them up to 10. And let's connect them here at the print string, at this one. And let's connect this print string and let them print like that after the game starts. Let me just change this color. Compile, save. So let's just play and see what the result is. The first is 0, the second is 1000. So 1000 is okay because we have 10 meters multiplied by 100, it's gonna be 1000. But the next thing is not correct because it's centimeters to meters. So what we need to do is we need to change it to float. I'm gonna change this variable type. And it's gonna change my blueprint over here. Here it's gonna say that we have an error. I'm gonna just disconnect it. And now I need to change this macro. So I'm gonna double click and go into my macro library. And I'm gonna go here and select them to be float. Select it float. All right. And when we connect this, we need to delete this one because you see that color is different. So it's working with integers. And right now what I need to do, I need to drag and drop here, use a divide operator. And now my operator is working with floats. I'm going to connect it over here. I'm going to put 100. All right. I'm going to save it. I'm going to minimize, open my blueprint. And here I have error. Let's compile it again. Done. So you need to redo this connection if you're changing variables. And in my blueprint, I need to drag and drop this one too in order to work. And now when I play my game, I see 0.1 meters and this is a centimeter. So that is pretty much how you create macros library. Here you can add a lot of different functions. For example, you can convert kilometers per second to meters per second and just do the mathematical operation over here, or everything reusable that you need in the game in your event graphs to drag and drop over here. You can create a library for it. Thank you for watching this video. I'm waiting you in the next one. Hello everybody and welcome to this next video. In this video we're going to be talking about enumerators, or for short enums. An enum type is a special data type that enables for a variable to be a set of predefined constants. So the variable must be equal to one of the values that we have been predefined for it. So let me give you a common example. A common example will be like a compass direction, like north, south, east, or west. Or maybe you can have enumerator with the days of the week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And this is basically the idea of enumerators. Let me create one enum here in Unreal Engine 5. So from the variables, I'm going to add a new one and call it enum1. All right. And from here, you can see that we have here enums, and there are a lot of different types of enums. Those are predefined enumerators Unreal has. And for example, let's select here in the search audio play. So play audio mode. I'm gonna compile, I'm gonna save. And here in the default value, we have enum1 with a drop down box over here, which is preset for play audio mode. We have direct set, random, or on death. So this play audio mode had those values here predefined in our enumerator. So let me give you a clear example. Let's say mouse, let's say click. So let's choose a button click. I'm gonna compile and save. And here in the button click, we have down and up, we have mouse down, mouse up, precise click. So those are actions in the enumerator, and they are predefined. Enumerators are very different than arrays. So the important thing in enumerator is that you can make lists that can be accessed anywhere in the game. So this is just the brief of enumerators, and in the next video we're going to deep dive and explain a lot more about enumerators. Thank you guys for watching, and I'm waiting you in the next one. Hello guys, in the previous video we just briefly talked about enums, and I'm going to show you how you can use the get and set enums. Right, I'm just going to get rid of this all, and here that enum that I've created, enum1, I'm just going to drag and drop it over here. I'm going to click get, and I'm going to create a print string over here. I'm going to connect my event begin play. I'm going to connect my enum over here. It's going to convert to string. All right. I'm going to boost the duration to 10, and I'm going to make this green. All right. So right now what we have is on our print screen in the game, we're going to have mouse up. All right. I'm going to compile, save, and I'm going to click play. I'm going to minimize. And as you can see here, we have mouse up. So what is going on? We have our enum with predefined list over here. And from the list, we've chosen mouse up. All right. And we print this on our screen. Another thing that you can do is, as I already have this button click method, I can go over here and open level blueprints. And here I can go into event begin play. I'm just gonna add this event over here. I'm gonna add a print string. I'm gonna connect it over here, and I'm gonna create a new variable, enum2. I'm gonna go here and I'm gonna search for click over here. I'm gonna select this one. I'm gonna compile and save, and I can select another option from the button click, for example, mouse down, and we can also access mouse up. So what we have over here is this enumerator e button click method holds a list of different actions. And for example, if we are creating a character, we can set up here our character is running, our character is crouching, our character is jumping, our character is riding a motorcycle, a car, swimming, etc. So we can create an enumerator which will define the status of our character over here. And this is the status of our mouse. So let's print mouse down. All right. I'm just going to drag and drop over here, get enum, connect it over here like that, compile, and I'm going to boost this to 10 seconds again, compile, save. Let's see what we'll have. We have mouse down and mouse up. They are separate from each other, the blueprint of the level and the blueprint that we've created over here. But the idea is that this enumerator holds the same list in our blueprints level and in our first blueprint class that we've created over here. So remember this, enumerators can be used for actions. For example, if you have a compass in your game, you have north, south, east, and west, and you can define here in enumerator and access it all over your blueprint or your code. And let me show you how you can set up an enumerator. So here in the set function, I'm gonna drag and drop over here, and let's set up, for example, precise click, and I want another print string over here to connect it. I'm gonna say again 10 seconds over here, and I'm gonna make it pink like that. And of course, I will need to define which variable will be printed over here, and I'm gonna compile and save. And right now what will happen is the first enumerator will go and print this string with mouse up. Then we set our enumerator to go to the precise click, and we're gonna print the string with this enumerator, but it will be changed to precise click. All right, so let's just test this pretty quick. Mouse down, mouse up, precise click, working like a charm. So this is how you can get and set enumerators. And remember this, that enumerator is a list of predefined stuff in your game. And very good example is the character that I've told you about. You can define running state, walking state. You can define when our character is in a car or it's outside of a car, maybe flying a helicopter like in GTA 5. So this is the base of how you can use enumerators and the get and set methods for them. Thank you guys for watching this one, and in the next one we continue with more sophisticated thing that we can do with enumerators. Alright guys, welcome back. Here is where we left off. We've talked about enumerators, the basics of it, and how to get and set enumerator. And we've talked about how we can access the enumerators that we already have in Unreal Engine 5. And now in this video, I'm going to show you how you can create your own custom enumerator and use it in your Blueprint class. All right, so the first thing that you need to do is I'm just going to create a new folder, and I'm going to call it enums. And I'm going to right click here. I'm going to go to Blueprints, and I'm going to select enumeration. So here I'm going to call it E for enumerator. This is my capital indication that this one is enumerator, and when I go into my search, I can just type E and search for all the enumerators in my project. All right, so I'm going to call it enumerator character status. So this will be my enumerator for my character status. So I'm just going to open it, and here I have a description and I have enumerators. All right. And in the description, I'm going to name it what this enumerator does. So I'm going to call it define character status. All right. This will define my character status. I'm going to save it. Let's close it. And if I hover on it, it will says E character status. And after that, we have the description, which is define character status. Let me just double click on it, and let's start at enumerators. So the first one will be walking, and let's put in the description my character is walking. All right, I'm gonna add a new one, running. I'm gonna copy this one, my character is running. All right, let's add swimming. Let's add the description, my character is swimming. And let's add one more, driving. All right, so those are defining my character status. And right now I've added walking, running, swimming, driving. Let's add one more, two more, crouch. My character is crouching. And let's add one more, jump. My character is jumping. All right, those are the status that I have. I'm gonna click save, and I'm gonna close. So right now we have enumerator for our character status. I'm gonna go back into my blueprint, and I'm gonna create one more variable, and I'm gonna call it enum character status. All right, so right now I've created my e character status in variable, and here in the variable type I'm gonna search for status, and I have this e character status enumerator. I'm just gonna select it, and right now my variable will hold, let's compile and save, will hold the status that I've shown over here: walking, running, swimming, driving, etc. So let me just show you if this is working. Of course, I'm just gonna drag and drop it over here, get status, paint it in the string, of course. And right now, by default, we have walking. All right, compile, save. Let's go back and start. And we have walking and mouse down. This mouse down is because we have in our level blueprint over here, we have that status over here in the print string. Of course, we can delete this one. And here in the level blueprints, we can add e character status. And of course, we can search here for the status. And we can have this over here. This is because our character status is global and you can access it wherever you want in each class. For example, this one for the map, you can have blueprint first, blueprint class, or you can have a class for your character and you can access it all over your project. All right. So we can have here driving. Let's get the get status. And let me show you that we're gonna have walking and driving and walking. All right, pretty good. Let me show you another method that you can do. We can create custom event. All right, and we can say that this custom event is swimming. All right, so right now what we can do is we can drag and drop here. We can set up our e character status to swimming. Let me select swimming, and we can set up that the swimming over here, let's compile and save, that this swimming event will switch our enumerator to swimming status. And how we can do that? Of course, from the previous videos, we've talked about it. Here in the graph, we have a new event, which is swimming. I'm just gonna drag and drop it over here, and we have swimming. I'm gonna connect over here. I'm gonna connect over here. And right now, what we're gonna have is we're gonna have this e character status set up to swimming. Let me just play it. We have driving and swimming. All right, pretty cool. We've created a custom event which is swimming over here, and it is working here in this blueprint. All right, and we can call it wherever we want in order to say that our character is swimming. Let me just create here another event. For example, custom event. Let's say what we have over here. Let me just check it pretty quickly. Let's say crouch. All right. It is called crouching. And we're going to connect it over here. Just like that, and we're gonna select crouch. All right, so right now when we start our level, our character will start crouching, and what we need to do, of course, compile and save. And here in our graph, event graphs, we have crouching. I'm gonna drag and drop it over here. I'm gonna connect it. Let me just connect it to the print string. Let me just move this a little bit to arrange it, just like that. And right now, what we're going to do is when we fire the crouching event here after event begin play, we're gonna set up this character status to go into crouch. All right. So right now we're gonna have crouch and swimming. This is pretty easy, pretty handy, and you can call it this status, this event, wherever you like in your blueprints over here, or you can call it in your new map over here. The event that we've created, crouching, you can call it wherever you want over here. So this is pretty much how you can create your custom event and how you can use it in different blueprint classes. So this is pretty handy to create different setup for your character, for different items that you have in game, for different character skills, etc. Thank you guys for watching this one, and in the next one, we're gonna deep dive and talk more about enumerators. Alright guys, welcome back. So in the previous lecture, I've told you how to create your custom enumerators. In this one, I'm going to show you just simple branch and how you can compare different values and create different logic and print it with the enumerators. Alright, so I'm just going to move this over here and I'm just going to disconnect. So right now what is going to happen is when we start the game, we're gonna trigger the swimming event, and after that we're gonna want to create a little bit of logic. So I'm just gonna go into my level blueprints, and I'm just gonna disconnect this one because I don't want this one to be printing. And right now what I'm going to create is I'm going to select a branch. All right, and here with this branch I'm gonna connect my swimming, and I'm gonna connect my true value over here to the print string. I'm gonna delete this one, and I'm gonna say that if this branch is true, our character is swimming. All right, I'm just gonna copy and paste this one, and if it's false, it's false. All right, it's not swimming. And right here in the condition, let me show you how you can connect your character status into our condition. You just need to drag and drop this the variable, and you need to select the get. All right, and you cannot connect it over here. It says it's not compatible with Boolean. And what we need to do is we need to create a Boolean for it in order to compare it in our branch. So I'm just gonna drag and drop over here, and I'm gonna type equal. And here in the enumerators, you can select equal or not equal. Let's select equal. And what this does is I'm gonna connect it over here. And what this will do is it will say that our enumerator, the character status, is equal to walking. It's gonna feed the branch with this data. And it will say here, false, it's not swimming. All right, let me just show you. Let's just play it. So it says false. Our character is not swimming right now because we are walking. And of course, you can change this to swimming. I'm gonna compile and save. I'm gonna play, and it says it's swimming. So right now our branch says it is true, and we execute the logic for swimming, for example, animation, and that the character can go into the ocean, and maybe you can drain some stamina if you want to swim quickly. So this is how you can create logic from here. Of course, we can drag and drop and say not equal, and you need to select the enum utilities, not the operator. So if I select the operator, it's not working with enums. What you need to do is you need to go to utilities, and you need to go here into enums and select equal or not equal. For example, if it's not equal, let's connect it over here. It will say that this is not equal to walking. All right, let's play. And it will say swimming. This is because it is not equal. If I select swimming, it will give us the false result, and we're gonna go into the false. So it says false. So everything different than swimming will give us the true result because we want to see the not equal result, which will return true. So this is pretty much how you can give your enumerators a little bit of logic through branches, all right? And this is how you can compare and create your logic through your Blueprint classes. So thank you guys for watching this one, and I'm waiting you in the next one when we're gonna continue talking about enumerators. Alright, so in the previous lecture we talked about the branch and how you can create different logic for your enumerators. Right now I'm going to show you a last one thing that you can do is with switch. I'm going to right click here and I'm going to type switch, and I'm going to type the variable name of our character status. So I'm going to type e character. And right now I have a switch for my e-character status. So I'm just going to add it over here, and I'm going to delete my branch and my variables. And here what we have is we have a switch condition, and we have all the status of our character: walking, running, swimming, driving, crouching, and jumping. And if I connect it over here and connect my swimming over here, of course, I'm going to need to connect the other ones like walking. Let's connect the walking over here, and let's arrange everything to be pretty clear. Let me just minimize those two so I can create more fluid thing. I'm gonna connect here my running, and I'm gonna need 3 more, which I'm gonna create over here. Next is driving, and following by crouching. Let's connect this over here, and let's connect one more, which is jumping. All right, so right now in our switch we have all our status over here, and what we can do is right now at the event begin play we trigger the swimming event. Let me just show you, and right now we're gonna print the walking, and this is because we've selected in our switch on eCharacter status, we've selected that our variable is walking. All right, and what we need to do is we need to set up our variable over here. We're gonna get the status, we're gonna connect it over here, compile, save, and let's hit play, and we have swimming over here. And this is because at this trigger, at this event, we set up the variable to be swimming, and here we call and connect the variable over here to our switch. If I delete this, our switch predefined that our variable is walking, and it will go into our walking status. So in order to create your logic and work properly in your blueprints, you need to set up an event for it, and you need to call it whenever you want your character to swim. And this is like hard coding in the switch what is your enumerator doing. So I can suggest that you connect here over your variable, and you can call the function inside your blueprints, and you can enable the switch whatever you would like to do. So let's say we are crouching over here. Let's say we fire our swimming, and let's say we are calling this crouch event, compile and save. And right now, when we fire it up and when we start our game, it will say crouch. All right. So this is how you can create different logic with switch. So you call the switch and you type the variable name of your enumerator. You connect an input to it. It is event begin play, or maybe you can input, for example, custom event. We can create a custom event, trigger player status. We can connect our trigger player status, and when we fire it up over here, it will read our enumerator and the default value that we've set up over here. And this is because our crouch event is not triggered at all. All right. So if you want to create a logic, we can create like that. Let me just show. At event begin play, we trigger our crouch, which will set up the value to the crouch. And then we're going to connect this, and we're going to trigger our switch, and this will be our crouch. Let me just show you. Let's just play it. It says crouch. But for example, if we do the opposite, we connect event begin play to our trigger player status. We don't call this, so this is not functional. And whatever we set up here, walking, it will be triggered over here. We're going to trigger this status. It's going to go into the switch, and the switch will read walking. And let me compile and save. Let me just play it, walking. All right, so you get the idea that we need first to trigger the crouch if you want to crouch, or you can trigger whatever you like on event begin play. So this is how you can use the switch function. Thank you guys for watching, and I'm waiting you in the next one.